All right, we're at 9:03. We'll go ahead and get started. So, good morning, everyone. Before we get started today, oh, I should say, next slide, please. Thanks, Colin. All right, before we get started today, today's workshop will be offered in English and Spanish. All participants must follow the interpretation prompts to select your preferred language option. To do this, first click the interpretation icon. It looks like a little globe and is located in the meeting controls at the bottom of the screen. Next, select English or Spanish. It's important that you select one of the two languages so that you can hear the presentation and the comments. I'll pause just briefly while people are doing some clicking. And I will also mention, if you want to hear Spanish only, please also select Mute Original Audio. If you're having any issues for technical assistance, please contact the moderators through the Q&A feature, and they will assist you as soon as possible. Next slide, please. Right. Now that everybody is getting situated, again, if you're having any issues, please go ahead, drop a comment in the Q&A, and our team will get back to you as soon as possible. I'd like to welcome everybody again to CaliPA's Vapor Intrusion Work Group's fourth workshop in our 2026 VI workshop series, Vapor Intrusion Holistic Approach Part 2, Path to Closure and Risk Management Decision Making. We're thrilled that you're here with us today. My name is Julie Johnson, and I am the Senior Engineering Geologist managing the Site Cleanup and Department of Defense programs in the State Water Board's Division of Water Quality. I will be the moderator for today's workshop. Today, we are diving into how cleanup decisions are made, specifically how regulators collaborate with responsible parties, communities, and others to use data to inform risk-based decision-making to protect public health and determine paths to closure using multiple lines of evidence. Think of this workshop as a behind-the-scenes look at how science, teamwork, and decision-making are all coming together. Next slide, please. So as I mentioned, today is the fourth workshop in our series, not counting the big kickoff, that event that happened last July. And each workshop has been helping us build a stronger, clearer picture of how CaliPA cleanup agencies handle vapor intrusion challenges and how collaboration and understanding among all parties leads to more efficient and protective project outcomes. And guess what? We will have one more workshop coming up. Our final workshop in the series is scheduled for June 17th, and we will focus on vapor intrusion data. That'll be our big finale, and we'd love for you to join us at that time. Keep an eye out for the announcement. Next slide, please. So before we begin the workshop, I'm just going to go through a few quick things to help everything run smoothly. So during the presentation, you will be in a listen and participation role. To keep the workshop focused, everyone's microphones will stay muted and chat and video are turned off. Automatic closed captions are on. If you want to follow along with the text on the screen, just click the CC button at the toolbar on the bottom of your screen. Please note that the chat feature has been turned off for this workshop. The CaliPA VI Workgroup team members will be using it to share website links, email addresses, speaker names, and other workshop-related information. If you have questions during the workshop, or if you are having issues with Zoom, don't panic, just grab help. Just kidding. Please use the Q&A button on the toolbar at the bottom of your screen. This is where you can send us your questions during the workshop, whether they're Zoom-related technical issues or content-related questions. We will answer as many questions as we can throughout the presentations and during the dedicated Q&A sessions after presentations. Next, I'd like to note that today's workshop is being recorded, and the recording will be posted online. By joining and staying here, you are agreeing to be recorded. The workshop is scheduled from 9 a.m. to 2 p.m. today, which I know is a very long workshop. So we have put in a few breaks for coffee and 40 minutes for lunch. Please note that if we finish all questions early, we may wrap up ahead of time. If you are not comfortable asking your question in the Q&A or we do not get to your question, please feel free to email us at dwq-vaporintrusion@waterboards.ca.gov. We've also placed the email in the chat for your reference. Now, a special shout out to anyone who is new to Zoom. Here are a few quick tips to help you feel like a pro. Number one, if you can't hear anything, click the little speaker icon on the bottom left and select Join Audio. If your screen freezes for a second, no worries. Zoom usually sorts itself out quickly. If you accidentally leave the meeting, just click the link again. We'll let you back in. If buttons like the Q&A or CC disappear, move your mouse or tap your screen and they'll magically come back. Sometimes you also have to click on the three little dots at the bottom of your screen where it says More, and those options should appear for you. Full screen mode is great if you want the slides to fill your screen. And one last thing, our presenters are joining from different locations throughout the state, so you might see some tiny pauses or hiccups along the way. Thank you so much for being patient and rolling with us. It really helps make today a success. Next slide, please. So as I mentioned, we will be posting the recording online, and workshop slides will be made available on the Water Board's FTP site approximately 2 weeks after the workshop. Also, if you want to go back and look at recordings and slide decks from previous workshops in the series, all of those are already available in the same convenient location. This means that you can revisit the information anytime or share it with somebody else who might be interested or who missed the workshops. The FTP link and login info are being posted in the chat for your convenience. Next slide, please. All right, so now the plan for today's workshop. First up, we'll have opening remarks from DTSC leadership. Following that, we'll have a recap of the previous workshops. Then we'll have a presentation on risk management and path to closure. We'll have a short break, 5 minutes. And following that, we'll go to case study number 1, residential development with offsite sources. We'll take a 15 minutes for Q&A after that first case study, and then we'll take another short break. After that, we'll come back and go through case study number 2, an open lot redevelopment case closure. Again, we'll have 15 minutes of Q&A after the case study. After that, we'll take a break for lunch. It'll be about 40 minutes, and we're aiming for noon, 11:50 to noon, just so everybody has some idea of when that's happening. And when we come back from lunch, we're really excited to host our industry partner panel discussion. Following that discussion, we will have an open Q&A session for about 30 minutes. And after that, we'll have closing remarks. As a reminder, this workshop is scheduled to run from 9 a.m. to 2 p.m., so with that 40-minute lunch. And we recognize that this workshop is quite lengthy, but it is also among the most vital session of the series. Your engagement and patience are truly appreciated, and we encourage you to stay with us throughout. Thank you for your commitment and understanding. Next slide, please. All right, everyone, I'd like to take a quick minute to introduce our awesome presenters for today's workshop. Each one brings something special, and they're all here to help us understand how we handle vapor intrusion challenges in California. First up, we'll have Roshani Dantas with the State Water Board, who will kick things off by providing a quick review of vapor intrusion and an overview of the previous workshops. Next, we'll have Jessica Law with the Santa Ana Regional Water Board. Jessica will talk about a couple of our most requested topics, risk management and types of case closures. This will set the stage for the case studies and the vapor intrusion partner panel after lunch. Next, you will hear from C.Y. Zheng with the Department of Toxic Substances Control and 2 of our partners, Eric Chavira of the City of Anaheim and Meredith Church of Verdantis, who will jointly present case study number 1, illustrating how lower risk, offsite investigations, and cleanup contribute to the path to case closure from start to finish. Our last presenter before lunch is Nicole Fry with the San Francisco Bay Regional Water Board, who will present case study number 2, which focuses on redevelopment of an open lot and associated risk assessment. As a reminder, we'll be hosting that vapor intrusion partner panel after lunch. That group will be discussing 4 main topics, including experiences with homeowner associations and community members, when to start considering cleanup needs and redevelopment endpoints, cleanup planning for affordable housing, and closure and long-term risk management decision-making. Next slide, please. So with that, let's go ahead and jump right in with some opening remarks from Craig Sanchez, the Technical Services Division Chief at the Department of Toxic Substances Control. Craig, the mic is yours.
Thank you, Julie. And good morning, everyone, and thank you for being here today. Today's workshop is the second part of our holistic approach to vapor intrusion. In this session, we'll focus on the path to closure and build on what we covered in part one, which highlighted moving beyond screening levels to making data-driven decisions that strengthen the CSM, along with best practices, including high-resolution site characterization, short-term vapor mitigation, and interim source removal. A true holistic approach to vapor intrusion finds the site-specific balance between indoor air sampling and vapor mitigation, often short-term, versus long-term, versus short-term source characterization, often using high-resolution methods and source removal. This provides a cost-effective method to protect human health first, while using the remaining financial resources to remove the source for long-term protection of human health. In discussing the path to closure today, we will expand on this concept as well as public participation, risk management, site-specific attenuation factors, long-term vapor mitigation measures, and financial assurance. Remember, this is not the last step in vapor intrusion. This is just the next step in moving the paradigm forward. Please feel free to reach out to me directly regarding this presentation or any site-specific questions or comments you may have. And now I will turn it back over to Julie.
Thanks very much for that welcome, Craig. Next slide, please. All right, so we're going to do a quick poll question. How often do you experience each of these types of challenges with site closure? I'll give everybody about 30 seconds to submit their selections. Answers that we have listed are property access challenges, funding challenges, risk assessment challenges, such as building-specific attenuation factors or future risk, challenges using and evaluating lines of evidence to support the path forward, and challenges developing alternative attenuation factors for establishing that path forward. I'll go ahead and we'll keep giving some time. I see lots of responses coming in. This is great. Thank you so much. All right, we're still getting lots of responses. Thank you, everybody, for participating with this. I'll give it about another 10 seconds. All right. It looks like responses are slowing down. Let's go ahead. All right, and so it looks like we have some results here. So it looks like the biggest ones that we have are property access challenges, the funding challenges. It looks like a lot of these I see frequently, almost all the ones that we have listed, and then occasionally is the property. Occasionally. Yeah, we have basically everything is a challenge, and that is true. These are some of the biggest challenges that we face uh, within site closure. All right, thank you so much. Let's go ahead and close this poll. Next slide, please. All right, and with that, I'll go ahead and pass it to Roshani Dantes to present the Vapor Intrusion Workshop Series Review. Take it away, Roshani.
Thanks, Julie. Good morning, everyone. My name is Roshani Dantes, Senior Environmental Scientist with the State Water Resources Control Board. I will be providing a brief recap of our previous workshops before we dive into our risk management and path to closure presentations. Next slide. So as we begin to evaluate path to closure for vapor intrusion sites, it is important to revisit the process that was taken to get to that particular point, including whether all the necessary steps have been taken and that site concerns were addressed. To start this evaluation, it is important to understand, why is the regulatory agency concerned about a vapor intrusion contaminated site? This goes back to the basic definition that a vapor intrusion site is a site where a release of vapor-forming chemicals into soil or groundwater has the potential to enter into the indoor air of buildings and directly impact the health of people living or working in that building without their knowledge. For these sites, the responsibility of the cleanup agency is to ensure this contamination is not impacting human health through the cleanup process. Next slide. Therefore, since a vapor intrusion site comes to a regulatory agency in many different stages, it is important that vapor intrusion is evaluated throughout the cleanup process, from initial investigation to monitoring and closure. Next slide. As we begin and move through the vapor intrusion evaluation process, one important step is engaging those impacted by vapor intrusion and the site cleanup process. Workshop number 2 in the Cal EPA Vapor Intrusion series discussed the priorities, tools, and strategies that are being used to engage the public on vapor intrusion sites. The need to ensure that the public and community concerns for vapor intrusion sites are addressed is one of the most critical challenges. Sometimes, depending on the site, lack of public engagement can prevent site closure. Therefore, part of a successful pathway to closure for a vapor intrusion site is understanding how to engage the public throughout the cleanup process. Next slide. A critical part of the vapor intrusion evaluation and path to closure process is building the conceptual site model. The conceptual site model is an iterative, living representation of a cleanup site that summarizes and presents lines of evidence throughout the cleanup site process. Therefore, it is a model that should be constantly updated and evaluated as data is collected. Workshop number 3 discussed the importance of collecting good data and site information to provide a clear picture of a robust conceptual site model for evaluating vapor intrusion and making site decisions. This may include evaluating who may potentially still be at risk from site contamination as compared to initial screening, collecting indoor air data so that it illustrates the occupied and highest vapor intrusion risk areas, for example, vapor conduits. These, as well as other considerations, are important so that the conceptual site model to make a risk evaluation looks less like this and more like this. Next slide. So how do we build that robust conceptual site model so that we can make effective site decisions, especially when evaluating paths to closure? Through a multiple lines of evidence approach. We use this approach to evaluate, weigh, interpret, and integrate site information and data to build the conceptual site model so we can answer key questions or data quality objectives. We will collect lines of evidence using a toolbox of techniques to answer our key questions, for example, passive soil vapor sampling, real-time indoor air sampling, active soil vapor sampling, etc. We continue to use this multiple lines of evidence approach throughout a project's lifecycle so that once the picture is painted, we can use it to make closure and risk management decisions. Next slide. One important line of evidence that is critical when it comes to move from conservative risk assumptions during screening to site-specific risk and closure evaluations is soil vapor characterization. When there are data gaps, especially for characterizing soil vapor, risk management and risk refinement can be difficult. For example, during the initial screening process before soil vapor characterization, it may appear that buildings 1 through 6 may need to be evaluated for vapor intrusion. However, if soil vapor is properly characterized laterally and vertically, our risk evaluation can be refined to only needing to address vapor intrusion risk at buildings 1 and 3. These screening to risk management steps are outlined in the final draft 2023 Supplemental Vapor Intrusion Guidance. Therefore, it is important to characterize a vapor intrusion site appropriately early on, using multiple lines of evidence to build a conceptual site model to support site-specific decision-making later on. Next slide. The appropriate characterization of vapor intrusion sites using this multiple lines of evidence approach is a key to adaptive case management best practices to support decision-making at vapor intrusion sites. This allows for better communication with the public, choosing the most appropriate cleanup method, and moving to more refined decisions for risk management and closure. Back to you, Julie.
Thanks very much, Rashani. Next slide, please. All right. And now I'll hand the virtual mic to Jessica Law to present on risk management and path to closure. Take it away, Jessica.
Thanks, Julie. So I'm Jessica Law, Senior Engineer and Geologist with the Santa Ana Regional Water Quality Control Board, and I will be talking about risk management and the path to closure. Next slide, please. All right, so the purpose of the first presentation is to follow up on the learning objectives from the conceptual site model, that holistic approach part 1 that Rashani just summarized. So I am going to start off by covering what regulators are looking for. Then I'll cover the path to closure objectives. What are the near and long-term goals and needs for the site? Next, I'll cover risk management. Some of the questions we as regulators ask are, will risk reduce over time? And what happens if the building deteriorates over time? And then I'll jump into the cleanup approach, and I'll end the presentation by highlighting the key takeaways. Following my presentation will be 2 excellent case studies, which will illustrate site-specific decisions making using the conceptual site model, multiple lines of evidence, and risk management to determine that cleanup approach and path to closure. Next slide, please. All right, so let's start things off by highlighting what regulators are looking for, and this image does consider all the factors, not just vapor intrusion specific factors. Also, this slide has been presented at other venues, so it may look familiar to some of you. Now, while the focus of the workshops are vapor intrusion based, it is important to answer all of these questions to establish that robust conceptual site model and develop the path to closure. And because this slide gives you that inside look at what regulators are looking for, I do recommend that you take a picture or a screenshot of this for future reference to facilitate that path to closure process. Now, I'm going to begin by emphasizing that community engagement is a key element throughout the project lifecycle. Effectively communicating your actions and soliciting feedback within the community, as well as understanding community concerns regarding site investigation and remediation, are essential for successfully navigating the path to closure. Next, we'll go over the top 3 boxes on this image. In the previous workshop, we explored how an adaptive or holistic strategy can foster a comprehensive conceptual site model by integrating multiple lines of evidence and identifying potential vapor intrusion issues. And this is accomplished by identification. We need to know what are the contaminants of concern and what media are affected. Delineation is another key item. We need to know how deep and widespread the contamination is, as well as source. What are the on and off-site sources of contamination? From there, we're looking at off-site impacts. Has contamination migrated, and is it impacting neighboring properties? Another component is the risk, considering both human health and ecological receptors, including protection of groundwater and natural resources. And as we move to the bottom portion of this image, collaboration throughout the process is vital. How can we work together to achieve health, safety, and reuse? Then their long-term protection is also key. How will the site continue to remain safe and protective in perpetuity? And lastly are the solutions. What needs to be done to address the contamination source or sources and make sure that exposure is eliminated or mitigated? And these solutions may include acceptance of risk-based cleanups and institutional controls. Now, the key is understanding the problem. For example, what are the source areas, plume extent, risk, so that we can determine and develop health protective solutions now and into the future. Next slide, please. All right, so when it comes to vapor intrusion, the case complexity informs the investigation and cleanup approach. What factors may contribute to the complexity of a case? A complex vapor intrusion case likely has multiple or large release areas with non-aqueous phase liquids. There may be a large groundwater plume with high concentrations. The site may also have complex geology and hydrogeology, and there may be a large number of buildings near the contamination. For a complex vapor intrusion case, this is going to require a more complex approach for both the investigation and cleanup. On the other hand, less complex vapor intrusion cases may consist of one small release area in shallow soils. There may be little or no groundwater contamination, and there may be few or no buildings near the contamination. For this type of a case, a less complex approach would be sufficient. Now, I want to point out that many of the case studies that have been provided so far in these workshops have been the more complex vapor intrusion cases. And because of that complexity, they do require a more complex investigation and cleanup approach. Now, the first case study that'll be presented today is going to be a more complex vapor intrusion case. The second case study that'll be presented is a less complex vapor intrusion case where a less complex investigation and cleanup approach is sufficient. Next slide, please. All right, so before I discuss path to closure objectives, I do want to first highlight that there are some terminology differences between the water boards and DTSC. And I'm going to do my best to point these out, but just know that the overall goal is the same. There are some agency-specific nuances, so communicate short and long-term goals with your regulatory agencies to make sure you are all on the same page and talking the same language. All right, so let's start talking about path to closure objective. And we all know, the obvious objective of no further action, but are there other objectives that we should consider along the way? Additionally, for some projects, no further action may be so far out in the distance that these other paths become vital for the site. Therefore, collaborative communication is necessary to understand the objectives so that we can provide better clarity to all stakeholders about these paths. And there is no prescriptive path to closure. Each site should be looked at case by case. So 3 common objectives ahead of a no further action determination would include first, suitability to occupy. Now, this is something that we can provide a county so that an occupancy certificate can be issued. It typically means that the cleanup and or mitigation are functioning such that the proposed occupants of the property will not be exposed to unacceptable risks, but that more remediation is still needed for that site. Next is remedy construction complete. This means the remedy has been constructed and is operating as designed to remove, reduce, and or control contamination and risk. It will include long-term operation of the said remedy, as well as routine maintenance and performance monitoring. Then we have a certified remedy with the land use control. This is typically an objective for DTSC cases. It means that cleanup activities have been completed, additional long-term mitigation measures may be in place, and a land use covenant or an LUC has been placed on the site. Now, with those land use covenants comes annual inspections and a more thorough review of the remedy every 5 years. Now, these first three objectives are ways that allow a property to be redeveloped and occupied despite not receiving a no further action. And these first three objectives, though, may come with financial assurance requirements. And these requirements differ from DTSC and the water boards. Therefore, it is important to talk to your regulatory case manager during the remedy selection process to understand financial assurance requirements. Then there's the low threat underground storage tank closure policy, which this is a water board specific policy used specifically for petroleum UST cases. This policy allows a case to be closed if contaminants are naturally attenuating and unlikely to pose an unacceptable threat. The policy includes a list of parameters or criteria that the site must meet in order to qualify for low threat closure. Lastly is no further action. And this can be a little different between the water boards and DTSC. So for the water boards, a no further action determination can include no further action with land use restrictions such as deed restrictions. It could be that cleanup goals are met or will be met within a reasonable time frame. Another scenario would be residual contamination poses that low threat to human health and the environment, and water board oversight of that residual contamination and any institutional controls such as those deed restrictions or site management plans are no longer needed. For DTSC, no further action, those projects are receiving that unrestricted land use and unlimited exposure designation. Next slide, please. So first we covered what regulators are looking for and path to closure objectives. So now we can move forward and start talking about risk management decisions and what goes into it, because risk management is a key detail that facilitates the path to closure. So this cartoon highlights three key risk components. First is risk perception, where the perceived risk at a site is a vapor-forming chemical that's been identified, and therefore there's the potential for vapor intrusion. Next is a risk assessment, and this is going to include current and future risk based on site-specific data. And lastly is risk management, which is the process of determining whether response actions are warranted to protect human health, and if so, selecting the response actions to implement. Next slide, please. So when risk is evaluated, there are two types of vapor intrusion risk that should be considered. First is current risk, which considers what people are currently breathing by looking at indoor air concentrations. When evaluating current risk conditions, it is important to note if the indoor air sampled was collected during a period that would evaluate the reasonable maximum exposure. Then there is future risk, which takes soil gas concentrations and models that future risk. And there are assumptions built into this, such as the attenuation factor. Now, calculating multiple risk ranges is a way to support the path to closure. And you can calculate future risk using multiple attenuation factors, such as the EPA's attenuation factor using the 95th percentile of 0.03 and the median of 0.003, or site-specific and building-specific attenuation factors, provided samples were collected that represent the reasonable maximum exposure and considers future changes that may increase vapor intrusion. Now, regardless, when calculating that future risk, it's important to consider those future changes to the site and buildings that may increase vapor intrusion, such as changes to the heating, ventilation, and air conditioning system operations, building remodeling, or new cracks or damage to the foundation or utility entry points. Also, site changes that may increase the capping effect may increase vapor intrusion in the future. Therefore, current building-specific attenuation factors alone may not be health protective when considering that future risk. Now, when a site has been adequately characterized and screened for vapor intrusion, moving away from 0.03 attenuation factor for evaluating that future risk may be considered, but it needs to be justified with supporting rationale and multiple lines of evidence. Right, next slide, please. So let's dive a little more into risk assessment. Now, vapor intrusion risk is the probability of an adverse effect caused by exposure to volatile contaminants of concern migrating from the subsurface into the indoor air of a building. Adverse effects on human health may result from toxicity, acute hazards associated with exceedances of trichloroethane or TCE or mercury, or potential explosions caused by elevated methane levels. Now, as a starting point for screening, which is also referred to as the point of departure, the vapor intrusion risk for that volatile contaminant of concern is generally set at a 1 in a million increased risk for developing cancer, or a hazard index of 1 for a non-cancer hazard, meaning if the hazard index is greater than 1, a non-cancer health effect is possible, but not certain. Click 1 for me, thank you. Unacceptable risk, as defined by the US EPA, is a cancer risk greater than 1 in 10,000 increased risk, or a hazard index greater than 1. Now, I want to emphasize that protection of human health is priority number 1. So when there is unacceptable current risk, quick fixes to address that unacceptable risk are necessary. And this may be identified early in the screening process. I want you thinking steps 2 and 3 of the California EPA 2023 supplemental guidance. You do not have to wait for the risk assessment to make risk management decisions for protecting human health now. If you click one more, to address that unacceptable risk, implementing one or more of the following response actions for protecting human health is priority number 1. There are short-term mitigation or time-critical removal actions, or even source removal and interim remedial actions that can be considered. The goal is to reduce the immediate threat to the risk management range listed below. So that risk management range listed below, that's the in between the point of departure and unacceptable risk. And the appropriate response actions are going to be dependent on site-specific considerations. As you can see in this image, there are multiple response actions. And these potential response actions, they are going to be dependent on current and future risk ranges and the hazard index and site-specific considerations such as stakeholder risk tolerance and the site end use, to name a couple. But the key takeaway here is you need to take an adaptive approach to addressing risk. Protect human health through quick fixes first, and from there, adapt and optimize the path forward, considering all of the technical and non-technical factors based on site-specific considerations. Next slide, please. Okay, so risk assessments support our risk management decisions, considering both current and future vapor intrusion risk. Now, the initial or preliminary risk assessment, these are going to use conservative assumptions. This should be sufficient to help determine appropriate initial response actions for most sites. And there are important considerations that we should be asking along the way when evaluating indoor air that may affect our future risk decisions, such as, is vapor intrusion occurring but not above the point of departure? Or does the indoor air sampling results represent the reasonable maximum exposure? Now, as more data and information are collected and the conceptual site model is updated, the risk assessment can be refined. The detailed analysis is used to replace those conservative assumptions with data based on site-specific lines of evidence to refine estimated risks and reduce that uncertainty. And it's important to note that if there are any short-term health hazards identified from contaminants such as TCE or mercury, appropriate mitigation measures should be implemented promptly. And a key takeaway here is that in an adaptive approach to vapor intrusion evaluations, risk assessments are refined as more information becomes available. And with more complete picture and characterization of current and potential future risks, the path forward can also be refined. I kind of like to say, if you are going right and you get more site-specific information that says to go left, let's adapt. Let's start going to the left. All right, next slide, please. So the California EPA 2023 Supplemental Vapor Intrusion Guidance included a lines of evidence attachment because using lines of evidence provides a more comprehensive understanding of vapor intrusion and reduces uncertainty in evaluating health risks from the vapor intrusion pathway. Now, it is essential that each line of evidence should first be weighted with a T based on relevance, representativeness, and quality. And please note that the weight of each line of evidence may differ by site, building, or even sampling event. Then the lines of evidence should be weighed, integrated, and interpreted together, even if some are ambiguous or conflict. In such instances, that requires careful evaluation and explanation of the line of evidence rather than just simply dismissing that conflicting line of evidence. Lastly, the formality of lines of evidence depends on the site's complexity. Lastly, with fewer lines of evidence, understanding of vapor intrusion decreases. Therefore, as regulators, using conservative assumptions is necessary to protect human health and the environment until more data is available. Now, case studies 1 and 2 will be showing how lines of evidence are weighted and weighed to assist with the risk management decisions and path forward for the site. Next slide, please. All right, so prior to talking about cleanup strategy, I would like to conclude this risk management section by emphasizing that essential elements that inform our risk management decisions for vapor intrusion. So first, we have current risk. This is what is informing that immediate risk management decision. We look at future risk because this is informing the longer-term risk management decisions. And it's those lines of evidence that are supporting the risk management decisions for the site. And ultimately, they must be protective of human health. Now, the holistic approach part 1 and the first part of this presentation focused on identifying what the problem is: source area, plume extent, risk. And now we're going to move into the cleanup approach portion of the path to closure. And I want to remind everyone that step 4 of the California EPA 2023 Supplemental Vapor Intrusion Guidance describes the process of using the characterization of health risks in all lines of evidence, qualitative and quantitative, to determine the appropriate response actions. Now, these are key technical considerations for vapor intrusion sites, but there are also other technical and non-technical factors such as feasibility, cost, community inputs that go into final risk management decisions. So what those response actions are will be site-specific, and those considerations are going to be discussed next, which includes understanding the goals for the site, the path to closure objective, so that the cleanup approach can be developed. Next slide, please. All right, so now we're shifting to the cleanup approach and the path to closure progression, and cleanup is the process. Now, regardless of the site-specific path to closure, The decisions must be protective of human health and the environment, and it must meet regulatory requirements. Now, cleanup authority does depend on the agency overseeing the work, but the goals are the same, protecting human health and the environment. Now, depending on the case and the regulatory agency, authority comes from the California Water Code, the California Health and Safety Code, the State Water Board Resolution 9249, and State Water Board Low Threat Underground Storage Tank Closure Policy. Next slide, please. So for vapor intrusion purposes, cleanup should be done to concentration levels that do not pose a current or future risk to building occupants. Now, a few slides back, I discussed what vapor intrusion risk is. So when screening a site for vapor intrusion risk, that point of departure is generally set to a 1 in a million increased risk for cancer and a hazard index less than or equal to 1 for non-cancer hazard. For determining the cleanup approach, site-specific considerations for deciding when vapor intrusion risk is unacceptable includes some of the following: the nature and magnitude of risk, both current and future risk. Short-term hazards associated with contaminants such as TCE and mercury. Understanding the vapor source threat. What is the estimated size and mass of the release area? And what are the estimated groundwater impacts below a building? The stakeholder risk perception and tolerance is another key consideration that may affect the cleanup approach. And lastly is the remedial timeframe. Next slide, please. So the cleanup approach is going to be in part determined by the complexity of the vapor intrusion site. Now, during the previous workshop, 2 complex vapor intrusion case studies were presented to highlight how an adaptive or holistic approach are used to develop that robust conceptual site model and identify potential vapor intrusion issues. The same goes with the cleanup approach considerations. Some of these other considerations for cleanup may include monitoring, non-remediation risk management measures, and active remediation. And I'm going to go into further detail on these 3 items in the subsequent slides. It is important to note that cleanup alternatives may include a combination of active cleanup, mitigation, and monitored natural attenuation. Now, mitigation is useful to reduce and control vapor intrusion-related risks, while remediation that permanently reduces concentrations in the subsurface is preferred. Now, as I mentioned earlier, when discussing the path to closure objective, make sure you talk to your regulatory case manager during that remedy selection process to understand the financial assurance requirements. Next slide, please. All right, so first, let's start off by discussing monitoring. Now, this is a key component throughout the project lifecycle. Monitoring will determine plume stability, which affects our risk management decisions. A plume that is stable or shrinking means the contaminants are not migrating any further and or deeper, and concentrations are not increasing. On the other hand, an expanding plume suggests that soil and or groundwater contamination that may require active cleanup, and that nearby buildings may need to be evaluated for vapor intrusion in the future as that plume migrates. And this data can be used to determine the path to closure and cleanup approach for the site. Now, monitoring provides information to also determine the effectiveness of cleanup activities and mitigation measures. And when the remedial action is complete, this is supported during post-remediation monitoring, focusing on areas of potential residual contamination, such as the capillary fringe and fine-grain lithology. Next slide, please. Next, we have risk management measures, and decisions need to be made on a building-by-building basis, considering the nature and magnitude of the vapor intrusion risk. These can include engineering controls, such as vapor intrusion mitigation systems, or the heating, ventilation, and air conditioning system modifications, how it's being operated. which are needed to mitigate unacceptable indoor air exposures until health protective cleanup goals are met. Then we have institutional controls such as land use covenants and risk management plans to ensure cleanup and mitigation measures remain effective. And then there's verification monitoring to demonstrate the effectiveness of mitigation measures and those cleanup activities. Next slide, please. So when implementing engineering controls, you need a plan. A vapor intrusion mitigation plan provides these key details to ensure the safe and effective implementation and operation, starting with a system design plan. This is going to outline the operation information. Also, it would include the startup sampling plan and would have an overview of the long-term monitoring plan. Now, there's also the need for a funding plan. Not all sites will need this, but if needed, this is something that's going to estimate the long-term costs. It will identify responsible parties for funding and propose financial assurance mechanisms if needed. And then there's the long-term operation maintenance and monitoring plan. And this is that final plan after the system is constructed and operating. And this plan may also include sampling data quality objectives such as detection limits and health risk-based concentrations. Next slide, please. And the last cleanup approach consideration that I want to discuss is active remediation, which from the regulatory perspective is the most important because permanent reduction of contaminants is preferred. So the first part is the objective of the active remediation. Is the goal mass removal and addressing the source area, or is it to manage the vapor intrusion pathway? When considering the cleanup approach, consider the long-term effectiveness. Does the remedial alternative permanently and or significantly reduce the current and future vapor intrusion risks, considering both low permeable and transmissive subsurface zones? You also want to consider the short-term effectiveness. Does the remedial alternative address risks to human health and the environment during the early cleanup process? And lastly, and very importantly, does the remedial alternative have community support? Consider if this remedial alternative exacerbates or corrects historic inequalities and environmental justice concerns. Next slide, please. So I want to close out this cleanup approach portion by going over what these paths to closure look like. So this first scenario, this is the ideal scenario where active remediation is conducted and feasible active remediation is complete, and the final soil vapor cleanup levels are achieved. And these cleanup levels are vapor intrusion risk-based levels using validated site-specific attenuation factors that use multiple lines of evidence and consider future changes to the site and site buildings. Based on the complexity of the site, there may be multiple attenuation factors if there are multiple building types and uses, but this is going to be site-specific. Now, the ideal scenario can be a no further action for both water board and DTSC cases. Next slide, please. This next cleanup approach includes monitoring until those cleanup levels are achieved. And this also applies to both water board and DTSC cases. So here, the feasible active remediation was completed, but soil vapor exceedances remain. To reach those final cleanup levels, monitored natural attenuation and or mitigation will be ongoing. Now, we're all familiar with monitored natural attenuation for groundwater, but we should also adapt and start considering this for soil vapor through dispersion. Now, monitored natural attenuation is an acceptable polishing step for groundwater, and it can be appropriate for soil vapor when the source has been adequately remediated. Routine sampling can determine concentrations are decreasing and support this as a polishing step. Also, mitigation can enhance that dispersion of the soil vapor plume. Again, only if the source area was adequately remediated, and it's that monitoring, that routine monitoring that will support that. Next step, please. Lastly would be a water boards only scenario, possibly also apply for the local agencies as well. And that is a low threat closure. It's similar to the last scenario where feasible active remediation is complete and there's some ongoing monitoring. However, this scenario, a low threat or risk-based closure is granted since the site data supports that the final soil vapor cleanup levels will be achieved in a reasonable time frame as determined and supported by decreasing concentration trends. Now, a reasonable time frame means that the cleanup goals will be met before significant changes in vapor intrusion conditions at these nearby buildings near the residual contamination are expected. Next slide, please. So I just want to close out this presentation by highlighting a few key takeaways on how decisions are made. So the more lines of evidence you have for your site, the stronger the conclusions will be. Risk management decisions will be based on multiple lines of evidence, and a site that is lacking in solid lines of evidence will result in a conservative path forward and conservative risk management decisions. And our risk management decisions are to be protective of human health and the environment now and in the future. Next slide, please. Also, establishing and implementing the path to closure is essential. And this is done through collaborative communication with all interested stakeholders, but especially between your regulatory agency and the responsible parties and consultants. Taking an adaptive or holistic approach throughout the project lifecycle. And then another one is transparency. When we all understand the project goals and what is going on with the path forward and the path to closure, this helps facilitate a successful project. Next slide. Back to you, Julie.
Thank you so much for that comprehensive presentation, Jessica. Much appreciated. There's been a lot of great questions in the chat. Our team has been active in the background answering those. We do recognize that there are still some issues with the FTP. We're working with our Department of Information Technology, our DIT, to get that sorted. So we are working on that in the background. We ask for your patience on that. And with this, we will go ahead and go to our first 5-minute break. We will return at 10:07 for our first case study presentation by C.Y. Jang, Eric Shavira, and Meredith Church. Let's go ahead and get that timer started. See you all soon.
Welcome back. I'm C.Y. Jang, the DTSC toxicologist. Next, we like to present a DTSC case study to show one example of path to closure on a residential development with an offsite source. And it's my pleasure to do this together with Eric Chavera from City of Anaheim and their consultant Meredith from Verdantis. Next. So here are the topics we'll be discussing in the next 45 minutes or so. First, I will go over the learning objective and case study highlights and turn it to Eric to provide site background. Meredith will do the bulk of the presentation, first on the residential development and cleanup, and then the offsite source assessment and ongoing cleanup efforts. They will also discuss the public outreach effort, which has been done throughout the process and is an integral part of the holistic approach. Finally, I will end with a summary on the path to closure process and key takeaways in this case. Next. So here are some learning objectives and highlights before we go into details. First, we want to present an example of housing development at lower risk properties impacted by an offsite source and allow the dual track on redevelopment and cleanup, which led to site certification by DTSC with land use covenant and vapor intrusion mitigation system with long-term operation, maintenance, and monitoring. Jessica just discussed the importance of addressing both current and future vapor intrusion risk for risk management. So the other critical piece is to show how investigations and cleanup was conducted to address the offsite vapor source that may pose future risks, which include use of traditional and high-resolution method that was discussed in the previous workshop for source characterization, prioritizing indoor air sampling at adjacent properties to protect human health, and conducting source remediation to reduce potential vapor intrusion risk. We also want to showcase the collective decision-making process and discuss the adaptive approach that was mentioned earlier, collaborative communication with all stakeholders, especially local residents, using of the public funding for offsite cleanup, and finally, taking an area-wide approach for the path to closure. I will now pass it to Eric and Meredith to discuss the case study and share site owners and consultants' perspective.
Thank you, CY. Next slide, please. So again, my name is Eric Shavira. I'm with the City of Anaheim's Housing and Community Development Department. I'm specifically working within the Affordable Housing Division, where we work with developers to help facilitate the production of affordable housing all throughout the City of Anaheim. I specifically oversee the environmental aspect of site development, overseeing cleanups, any type of remediation that we have to do, prepping the sites to be able to build affordable housing. So today we're going to be talking about two specific sites. One we'll call the source site, and the other site, the housing site where housing was essentially built. But I think before we get into that, it'd be good to get a understanding of some of the background of where this site's located. So this site was owned by the Anaheim Housing Authority, and most of our sites that are slated for affordable housing are owned by the Anaheim Housing Authority. It's located in the greater downtown Anaheim area. And so if you're not familiar with this area, it's really become a hub for tourists. There's the packing house, which is shown here on the screen on the left corner, which is, was an old packing facility, and now it's essentially a tourist hub. This area has a history of, changing, and with that change were, the past uses, which included, industrial, commercial uses. The sites that we're discussing were located on, with former dry cleaners, automotive shops, and anytime we're assessing a site, we do our due diligence, and we work with our environmental consultants. And Meredith with Verdantis will be speaking a little bit more deeply into, the remediation work that needed to be done to be able to build the housing. And so with that, I will be passing it over to Meredith with Verdantis. Thank you.
All right, next slide. Thank you, Eric and CY, and good morning, everyone. My name is Meredith Church. I'm a professional geologist at Verdantis. I've had the great pleasure of working with the City of Anaheim since 2006, and I've been working with DTSC at this site since 2012. Now, by this point in the presentation, especially if you've listened in the previous workshops, you should be well acquainted with what vapor intrusion is and the various means and methods of investigation. But what I'd like to do in this presentation, which has a focus on path to closure, is to go over the big picture steps that are taken from beginning to end of a development project. And since this is a community-focused workshop, I want to address some of the primary concerns that I've heard from residents that I've worked with. So, as Eric noted, the city teamed with us to do an environmental due diligence on a property that they were seeking to develop with residents that's in a prime part of Anaheim. So, the first step that is taken is to conduct what's called a Phase 1 Environmental Site Assessment, or ESA, which I like to call a big giant history report. And that's in order to identify the entire documented site history of a property. And you do that through looking at things like aerial photographs, permits, and a lot of other historical documents. So we completed a Phase 1 of this site in 2008, and during that we did identify a number of environmental concerns on site that included a former gas station, there had been some auto repair use, a printing facility, lumber yard, and a railroad depot. All of these businesses have used products that are considered as hazardous materials. So if there's a spill that occurs, it's possible for those to get into the ground. In addition to the on-site potential concerns, which some of them had already been addressed, like the gas station was already gone and had been remediated and cleaned up. But in addition to that, there were also off-site documented release of tetrachloroethylene, which is also known as PCE, into the subsurface, but it had not yet been investigated on site. Next slide. So on this slide, if we can get to the next one, so we see our area outlined in pink. And to the left of that, there are two auto body garages that are located directly to the west. The second shop to the west had been identified to be a former dry cleaners in the 1960s. Now, dry cleaners are one of the most common sources of PCE contamination, which, by the way, is why California has banned its use in dry cleaning. Assessments conducted previously at the adjacent property to the north, which is noted in the green sample locations, had identified a potential offsite source of contamination. So then we conducted assessment within the public right-of-way, which is depicted as those blue locations. Then we had done the Phase 1 on this residential site. And so after we did the Phase 1 and we identified these concerns, we then did a Phase 2 ESA. And during this Phase 2 environmental site assessment, we collected numerous soil vapor, and groundwater samples to assess for contaminants of concern, also known as COCs. So our site COCs included primarily heavy metals, petroleum hydrocarbons, and volatile organic compounds, which are also called VOCs, and PCE is a type of VOC. So we did identify that there were some minor lead and petroleum hydrocarbon impacts on site. We delineated those during supplemental assessments, and we recommended that those impacted soils be removed. Once all of the on-site buildings were demolished, we then completed the on-site remedial work, which included removing those impacted soils. During the demo activities, a concrete encased ink pit associated with the former printing facility was encountered, and that is shown as in a black circle area on the north part of the site. So that pit was removed, and then we did additional soil and soil vapor sampling after that removal. So the orange lines on this map show the PCE concentrations in soil vapor at the site and in the adjoining right-of-way. Those contour lines are tightest and form a shape pointing right to those adjacent properties to the west. And in the street to the north, you can see those contour lines also point down toward the second auto body shop where the former dry cleaners had been located. So on site, there are also some tighter contour lines right where that ink pit had been located, and inks can also contain VOCs. So our subsequent soil vapor testing showed that those PCE concentrations did decrease a lot on site following the removal of that ink pit. But they continued to be extremely high in that northwest corner of the site, pointing right towards where that former dry cleaners had been. And this is a pretty common scenario that you see in California, where you have a site with either no concerns or maybe minimal concerns like this one that can be relatively easy dealt with, but then you have a really large offsite problem. You can't remediate your on-site impacted soil vapor when you have a much larger offsite source. But you don't want to leave prime real estate vacant, run down, when there are mitigation measures that you can utilize that will allow that to be safely developed. So we conducted health risk assessment that indicated that with proper mitigation measures employed for a new residential development, that it would be protective of human health and the environment. Next slide, please. So to backtrack just a little bit towards our assessment phase, I did want to note that we included multi-nested soil vapor sampling down to groundwater, which was at approximately 80 feet below ground surface at this time. We also collected groundwater samples and find that there were also high concentrations of PCE in the groundwater up to 81 micrograms per liter, and in the soil vapor directly above that groundwater at 414 micrograms per liter, with decreasing concentrations as you go upward towards the surface. This is a very common occurrence when you have an off-site contamination source. We collected discrete soil samples for analysis and determined soil type. In addition to the discrete sampling, we also conducted cone penetration testing, or CPT testing. This is essentially a hydraulic push drill rig that uses a device that continuously records data as you push that rod into the ground, and essentially gives you a picture of the soil type. We use this data along with the discrete soil samples that we collected to give us a cross-section of our lithology, to help us understand what is going on underground and what's the best way to deal with this. Next slide, please. So this cross-section shows that the subsurface is largely sandy material, with some interbedded sandy silts with some clay at depth, and then gravelly sand starting at about 75 feet below ground surface. A PCE is a dense, non-aqueous substance that easily travels downward through sandy materials. If you have dense clays, that can actually help impede the downward migration. But these sands like this just easily allow for that PCE to continue downward and enter into groundwater. So speaking of groundwater, it's interesting to note that the depth of groundwater in this area has varied considerably through the years. Interesting, but maybe not all really that surprising for those of us who've lived through the drought cycles here in Southern California. As I mentioned previously, depth of groundwater was at approximately 80 feet below ground surface in 2012. During later investigations conducted in 2016, depth of groundwater was actually at 102 feet below ground surface. And there's probably a lot of you who remember that we were experiencing a really particularly dry period for several years during that time. Most recently, in just the last few years, the first groundwater occurrence is now at 67 feet below ground surface. So for the consultants out there, when you're planning your screen intervals, make sure that you are utilizing current data and not just relying on older data, as conditions can definitely change. Next slide, please. So our next step in the process was to develop a conceptual site model. So while this site is a relatively complex one, as Jessica had noted, due to the extent of contamination, the high concentrations, the number of areas that are impacted, we do have a relatively simple lithology or soil types and a pretty basic CSM. So we have an offsite dry cleaners that had a release downward and impacted groundwater. Those vapors then can migrate laterally out directly from the release site, but they also, when they travel into groundwater, they can go even further. So the vapors then off-gas from that contaminated groundwater into the soil above. They migrate upwards towards an area of less pressure. And then those vapors can then, once they get near the surface, they can travel through cracks and utility lines into your houses or places of businesses. And I'm sure, as we all know by now, that is what vapor intrusion is. Next slide. All right, so we want to safely build new residences on this site. And what is the best way to go about doing that? Well, we've done a really robust site characterization, and at this point, we requested regulatory oversight from DTSC, who reviewed all of that data that we collected over many years, and we used this to evaluate alternatives for mitigation and cleanup. And this was documented in a removal action plan. The remedy that was selected was to install a vapor intrusion mitigation system, also called a VIMS, at each of our new residential structures. So the new development is shown on this slide, and we're still looking upward towards the north with the dry cleaners in the northwest. This consisted of multi-level condominiums with 4 buildings on the western side and then 2 larger buildings on the eastern half. So the former dry cleaners have been located on the northwest of the development. That's where our largest impacts are. Each of those buildings on the western side was constructed with ground level parking, and the living spaces started on the second floor. So only garages were at the ground level, and that acts as an extra buffer against vapor intrusion. So your building design can also be part of your mitigation system when the living space is not at the ground level and has one or more parking levels beneath. During this phase of the project, we did also conduct extensive public outreach. I'm going to talk a little more about that towards the end of our presentation though. Next slide. So this slide shows the cross-section of our passive vapor barrier system that was designed for the site. The plans were prepared by a remediation engineer and reviewed and approved by DTSC. The system includes a thick membrane beneath the foundation of each building with a venting system that diverts those harmful vapors out the side of the building to prevent them from building up below the foundation slab and then possibly migrating into the building. The system also includes 12 paired upper and lower barrier probes for the 6 buildings. Next slide. After the BIMS is installed at each of the buildings, it's important to verify that it's working correctly. So we do this by first preparing an operation, maintenance, and monitoring manual that describes the routine monitoring that will be conducted, screening levels, and also any contingency mitigation plans. So we conducted 4 baseline monitoring events over a 4-week period. And that baseline monitoring that we did demonstrated that the BIMS was working as intended and that the units were safe for occupancy. So this is a very important step in the process, as now we can have residents move into their new homes and feel confident that there's been a very diligent process that's gotten us to this point. So although we've just demonstrated that there isn't a current risk, we want to continue to monitor so we can be confident that there's not going to be a future risk. We've conducted routine quarterly monitoring of the lower barrier probes and inspections for a period of at least 2 years. Then it was shifted over to a period of semi-annual monitoring to continue to demonstrate that the BIMS is working and that it is protective of the occupant's health. Contingency planning at the site includes immediately retesting of any probes if the action levels are exceeded, and then converting that system to an active mode in consultation with DTSC if the action levels continue to be exceeded, which we have not had to do at this site. All right, next slide. This graph depicts our data trends of PCE concentrations in the lower probes. So it's natural for concentrations to trend up and down within a specific range like they are shown on this graph. What I hope you don't see in a graph like this is a continuing upward trend in concentrations. That can actually happen if you do have an ongoing release, or if you have migration moving of a large uncontrolled contaminant mass towards your site. Now, of course, what you would prefer to see in a trend graph is a decreasing trend in that contaminant mass. This is something that you do often see in the gasoline release sites because gasoline actually naturally attenuates pretty well over time. PCE, unfortunately, is very persistent in the environment. It attenuates very slowly and generally requires active remediation to substantially reduce the concentrations. Next slide. So, as Julie noted in the previous presentation, the path to closure can vary by site and by agency. Any site regulated by DTSC that has not been cleaned up to a point where it can receive an unrestricted land use designation and requires a mitigation measure in order to be protective of the occupant health must have a land use covenant executed in order to document the conditions of those restrictions. Some of the conditions of the LUC, which we shorten it to sometimes, on this site includes documenting that the garage is not to be used as living quarters, and that nothing could be installed in the garage that would penetrate through that vapor barrier, which would then allow for vapor intrusion. In addition to a yearly LUC inspection that's conducted, there's also a 5-year review, which reviews all of that data over the last 5 years, your action levels, also looks at any regulatory changes and toxicity updates. And this is done in order to assess that the mitigation is still appropriate or see if there's any changes that should be implemented at your site. Next slide, please. All right, so now we have a site. It has a certified remedy with a land use covenant. We've done routine monitoring to ensure that this remedy is effective. There's also been a financial assurance set up for the site. So what is next? Can we get a no further action letter from DTSC now? Well, the short answer is no. Not while there's a significant off-site source that requires any type of mitigation measure to allow the residences to be safely occupied. Further risk can change, so DTSC requires a continued demonstration of that BIM's effectiveness. Next slide. All right, so let's go to the source then, because that's the only way you're ever going to get a no further action on the offsite when you have a really large contamination like this, is to go to the source. So luckily the city has been very proactive in wanting to clean up the source at this former dry cleaners. They purchased a property in 2018 and have conducted additional soil vapor, and groundwater sampling at the source site, as well as on surrounding properties. So it's evident from this plume map of our PCE and soil vapor that the former dry cleaners is indeed the primary source of the PCE release. The maximum PCE concentrations we've identified on this site have been up to 2,500 micrograms per liter, and that's about 12 times greater than what we've seen at that northwestern corner of our residential site. And then it drops pretty quickly from there as we move eastward. In addition to the subsurface testing, the city has also conducted indoor air testing at the auto repair businesses at the source and next to the source to assess vapor intrusion. Next slide, please. In addition to the indoor air testing at those auto shops, indoor air testing was also conducted at the adjacent residences to the north of the source site. Paired indoor air and crawl space samples were collected utilizing SUMA canisters and collected over a 24-hour period in both the summer season and the winter season. That data indicated that in the summer, the risk from vapor intrusion from the former dry cleaners release was only 1 in a million. In the winter, it was slightly higher at 3 in a million, but still within that risk management range. Next slide, please. All right, but we still have a large release at our source site that needs to be cleaned up. So the remediation of a property with a release of this size is generally very expensive. So the city sought funds in order to conduct additional assessment and remediation pilot studies. They were awarded an ECRG grant from DTSC in 2022. So thank you very much, DTSC. It's been very appreciated. That has allowed us to do a significant amount of work on site. This has included grid-based soil sampling to identify the limits of that PCE impacted soil above those regulatory screening levels. In addition, we identified soil impacted that was also impacted with heavy metals, including lead and arsenic, that was from the former auto repair operations. Those impacted shallow soils, to a depth generally of about 3 feet below ground surface across the site, had been removed. There was also an area where the primary PCE release was identified, and we've removed soils in that area down to 7 feet below ground surface. Supplemental soil vapor assessments have also been conducted at that source site and surrounding properties. We also conducted soil characterization activities using a membrane interface probe with a hydraulic profiling tool, also shortened to be MIPD, that has helped us identify where the primary PCE contaminant mass is located in the subsurface. That is primarily in those sandy units directly overlying any of those thin interbedded sandy silt with clay units that we have. So if you're a consultant, you're developing a remediation strategy, I highly encourage the use of the MIPD tool. It's really invaluable in providing data that can be really difficult to get otherwise when you're only using discrete sampling. We use this data to install a network of clustered soil vapor extraction wells that are appropriately screened in order to provide the most effective extraction of those impacted vapors. We've conducted a soil vapor extraction pilot study, and it has been shown to be very effective and can be employed as a long-term remediation strategy. This is a good time to note that the maximum PCE in soil vapor that I had noted before prior to any soil excavation or activities was 2,500 micrograms per liter. After that soil excavation across the site and in the source area, we had a maximum concentration of 442 micrograms per liter. And following the SVE pilot study, the max source site concentration has been reduced down to 170 micrograms per liter. This is still a high concentration that will take time to get down where we need to be, and the city is in the process of seeking an EPA grant in order to implement a full-scale SVE system. Lastly, as part of this current grant, we have installed a groundwater monitoring network that has included clustered on-site wells within the first groundwater occurrence, so that's screened between 62 to 82 feet below ground surface, as well as a deeper screened zone between 115 to 125 feet below ground surface. Next slide. This slide shows the data output that comes from your MIP team borings, and it's really good at correlating lithology from CPT data with the VOC data from that interface probe, and the spikes that you'll see in the data correlate with increased concentrations of PCE. Next slide. We've collected groundwater data from our monitoring well network for about a year now, and it paints a picture that we're still trying to figure out, as the groundwater trends don't necessarily correlate with what you would expect to see from the soil vapor data at all locations. You'll also note on this slide that during the latest monitoring period, our highest groundwater concentration, which is 350 micrograms per liter in the screened zone from 62 to 82 feet below ground surface, is actually to the west of the source site in a well that's located within the public right-of-way. Now, during the previous monitoring period, it had actually been the exact same concentration both on-site and at that off-site location at 260 micrograms per liter. We recently did another review of all the off-site properties just to see if we could find any other potential source. We haven't identified another potential source with the possible exception of that neighboring property to the west and directly fronting that high concentration. However, soil vapors from that property are relatively low in comparison to the former dry cleaning property. So we're still in the process of assessing this trend and installing an additional well to the west and another to the southwest. With this data we're gathering is going to be used to develop a groundwater pilot study that we're planning to implement later this year. Some good news that we have is that the lower screened wells in that 120-foot zone on site had a maximum PCE concentration of only 1 microgram per liter. And below that, there's a clay confining unit that we did not drill through as it was relatively thick and we didn't want to go down deeper. So with the low concentrations of PCE we have at the bottom and that confining layer, it does not appear that PCE would have a chance to have impacted your much deeper drinking water aquifer. Next slide, please. All right, so something that's been talked a lot about in this workshop is utilizing the multiple lines of evidence in order to support your path to closure. We've been able to check off many of those lines of evidence that support our certified remedy with monitoring and land use controls at the residential property. We have a very detailed site history, extensive site characterization, a stable and controlled plume. We have new construction with no ground level living space from that primary plume areas, and all of these indicate that the site continues to be safe for occupancy. However, there are those few factors that remain high which prevent a full no further action status at this time. And that's that we have those high concentration contaminant source that is nearby within coarse-grained material. But with the source removal process started, as we're moving closer to having a chance to reach that no further action status that everyone is hoping to achieve someday. Next slide. All right, so here's a part of the presentation where I'd like to address some of the big concerns that I've been asked from the homeowners associations where we're conducting routine vapor intrusion monitoring. Most community members have never heard of vapor intrusion before, and they don't understand why it needs to be done. So I always let any HOAs that I'm working with know that I'm more than happy to join on one of their monthly meetings to talk them through the process and answer any questions they have. The first question they usually have is, why do we have to do this monitoring in the first place? And I generally will give them the background information on the site. And then the short answer is simply to protect your health and the health of your loved ones. The long answer also includes many points we've talked about over the course of this workshop, one of those being a state requirement that does for DTSC that requires them to continue annual inspections for any site they've certified as safe for occupancy and that has a land use covenant associated with that. Next slide, please. So another question that I get frequently from the HOA is, why do we have to pay for this? Well, the reason for that is because initially the developer or the property owner was going to do all the initial assessment, and they implement an approved remediation or mitigation strategy. They also have any long-term monitoring costs calculated. They set up a financial assurance bond for the DTSC cases and for some of the water board ones as well. And they build those costs into the HOA dues. So once the property is transferred over to the new owners and the HOA, it is now the HOA and everyone's, all the residents' responsibility to continue that monitoring and incorporate those costs into the dues. Next slide, please. All right, our next big question. Why does it cost so much? Well, the cost for each site is really highly dependent on a lot of factors, such as how many monitoring locations do you have? Are there monitoring wells for groundwater or deeper soil vapor that's associated? What is the concentration of your contaminant and other factors as well? There's a lot of components of the monitoring program. These generally include a mobile lab, sampling and inspections, a written report, and data that has to go through multiple levels of review. And that agency review by several top-level experts so you can have the confidence that your family's safe. As the consultant doing the monitoring, I always work to keep our prices as low as possible for the HOAs because I know that all of you guys are just like me, and I'm definitely always doing everything I can to keep my personal expenses as low as possible. So I try to do the same thing for you. All right, so I have one final question to go through. So next slide, please. And my last most common question that I get is, when are we going to be able to stop the monitoring? I wish I could give an easy answer for this one, but it's different for every single site. Some sites with small releases might be able to be fully remediated and not even require any engineering controls and be able to receive closure before construction even commences. Some sites you might be able to monitor for 5 years or so, demonstrate that the site's being cleaned up satisfactorily, and the monitoring is no longer needed and receive closure. And then there's some, like this site, that's going to be a much longer term monitoring. And if that source is not able to be remediated for one reason or another, it really just depends on your location, concentration of the contamination, your health risk assessment, and those multiple lines of evidence that we've talked about in this workshop presentation. But the most important factor is that we have a well-designed mitigation system in place, and the steps are taken to move towards a no further step, as those steps are taken to move towards that no further action letter. Those steps do continue to be made on this site as we progress through the source removal remediation phase. Next slide, please. So as I mentioned earlier in this presentation, that I would discuss the public participation process at the end. And the reason that I did this is because this is my last slide before I pass it back to Eric, who will also discuss the city's role in public participation. So way back earlier in our process when we did that removal action plan, because anytime that a removal action plan or a remedial action work plan is prepared for a site, it's going to trigger a mandatory public participation process, because it's very important to our regulatory agencies that the community is aware of what's happening and that they can ask any questions that they want. So this public participation process includes sending out community surveys, mailing out fact sheets, and allowing for a public comment period, and then having a public meeting if that is requested. So if you ever happen to receive a survey in the mail about a project in your area like this, and you want to know more about what is happening in your community, fill out that survey and mail it back in, because everyone is here to answer your questions. In addition to the public participation period, we've also done public notifications throughout this project whenever we're doing work that would impact neighboring properties, such as road closures or closed parking spaces or making a lot of noise. We always try to be as mindful as we can about our impacts on the community. We're here to make your neighborhood a safer place to live. And with that, I wrapped up my portion of the presentation, and I'm going to pass it back over to Eric.
Thank you, Meredith. Such a wealth of information. And as you can all see, these environmental cleanups are very complex, which is why we lean on our environmental consultants and professionals like Meredith and the Verdantis team to help get these sites cleaned up. So now I want to, oh, can we go to the next slide, please? I'm sorry. Now I would like to briefly touch on the public outreach that we did for the source site and that we're continuing to do as part of that cleanup process. So again, I mean, public outreach is hugely important for us. We want to make sure our neighbors, our residents are aware of what's going on within their neighborhood. So here depicted in the picture is myself and a colleague at one of our district community meetings. So the city is broken up into 6 council meetings, and we have a district community meeting on a quarterly basis where residents are able to come out, learn about different things going on within their neighborhoods. And so we thought this would be a good opportunity to discuss, our source sites, some of our ECRG fundings, and provide them an opportunity to ask questions. In addition, we also sent out mailers. We posted in our newspaper publication, and then we do door-to-door, outreach where we're talking with our neighbors. And then another thing that we also have our consultants do is them do the same. So some of the neighbors around these sites that we've discussed actually know Meredith and her team by name, and as well as myself, I provide them with my business card, and they have a point of contact from both the consultant side and also the city side. So public participation is hugely important, and it'll continue to be important as we move through getting the source site cleaned up. Next slide, please. And so again, none of this would be possible without funding. And unfortunately for us, working on behalf of the Anaheim Housing Authority, a lot of our fundings aren't available for remediation of sites, to clean up sites. So we really have to go out and apply for grants, apply for different funding opportunities to be able to get these funds to be able to clean up the sites and get them ready. So just kind of a brief timeline of how we've gone about getting some funding. So the city had applied for a water board, SCAP cleanup grant, but unfortunately that was delayed. So, we kept our heads up and continued to apply. And then eventually we're awarded that DTSC ECRG funding, which has been huge to get this project, closer to being able to be developed. And then in 2025, and I'm sure a lot of folks on this call are also waiting to hear back from the EPA on the cleanup grant. We applied for EPA funding, so fingers crossed we're able to get some additional funding to help, implement that full-scale soil vapor extraction system. And with that, again, takes a lot of work and a lot of funding and a lot of individuals to get these sites cleaned up. But with that, I want to turn it over to CY to close this out. Thank you.
Thanks, Eric and Meredith, for going through the various aspects of the projects. So here's a summary on the key steps for the path to closure process in this case. First, proper site assessment to build a robust conceptual site model. And the tools used in this step include phase 1 environmental site assessment to identify recognized environmental conditions, followed by phase 2 ESA and supplemental site investigation and a human health risk assessment to evaluate vapor intrusion and other risks. The city engaged DTSC after initial investigation and throughout the process, which is critical for reaching key milestones and keep project on track. And eventually, DTSC issue a site certification. Once the site is properly characterized and a robust CSM was developed, a removal action work plan overall was prepared for remedy selection and went through public comments. The stakeholders, including affected community, were engaged and informed of the final decision. which include installing a building protection mitigation system and preparing a operation and maintenance manual. Last but not the least, the effectiveness of the remedy was evaluated before the building was allowed for occupancy. Currently, we continue to demonstrate remedy effectiveness by conducting routine operation maintenance and monitoring for the mitigation system, and also focus on cleanup of the offsite source. Next. So the final step is to rely on site-specific lines of evidence to support site closure for both projects. The table lists lines of evidence applicable to the on-site and off-site properties separately. For the on-site portion, there are many favorable lines of evidence for low vapor intrusion potential that both Jessica and Meredith discussed earlier. And I'd like to point out the two key lines of evidence in particular to support there is no current VI risk. First, the mitigation system and ongoing OMM and monitoring to verify the buildings remain protected. And second, the offsite source is being remediated and under control. However, there's still potential future vapor intrusion risk due to presence of an offsite source until it's fully remediated. While some of the same favorable lines of evidence are also applicable to the offsite properties, there are three pointing to high vapor intrusion potential or uncertainty, high persistence for PCE, conducive subsurface condition with coarse grain soil, and the presence of vapor source from the former dry cleaner operation. These conditions together pose future vapor intrusion risk, and the PCE source need to be remediated before both sides can reach final site closure. Next, please. So to recap, these are some key takeaways from the case study. First, a vapor intrusion mitigation system was installed and integrated with housing development to address current vapor intrusion risk. As a result, DTAC issued a site certification with land use covenant and require long-term operation maintenance and monitoring. Also, engagement with the community was conducted throughout the process. Offsite source assessment and cleanup is the other critical piece to address potential future risk, which include use of traditional and high-resolution methods to characterize the source, prioritizing indoor air sampling at adjacent properties to protect human health, and securing public funding for source remediation. However, there are still a few challenges remaining before reaching final site closure. First, Meredith mentioned about homeowner association. They are taking the financial responsibility for the mitigation system for the residential development, but hopefully the burden on homeowners will be removed once the offsite cleanup is complete and mitigation is no longer required. Eric mentioned about additional funding is still needed to complete the offsite cleanup. And finally, regional groundwater impact is still being assessed and may affect final closure strategy. Next. Thank you for your attention, and here is the contact information if you have questions and like to follow up with the presenters. So with that, next slide. Julie, I think taking over.
Yep. All right. Thank you so much, Meredith, CY, and Eric. That was really fantastic. We'll go ahead and start our 15-minute Q&A for this first case study. I do want to do a quick note, next slide, please, that we're running a little behind schedule right now. So we're really going to try and focus in just on questions on this first case study. Thank you, everyone, for putting a bunch of your questions into the Q&A. Our team's been super busy in the background providing answers to those. So just a quick couple things here. So again, you keep using that Q&A chat. If you want to ask a verbal question, raise your hand and I will call on you and prompt you to unmute. And when I do, I ask that you state your name first and last and your affiliation. We are asking that you ask only one question at a time so we can make sure to provide full responses. And for phone users, please do *9 to raise your hand. And when I call on you and prompt you to unmute, do *6 to unmute and then *6 again to mute yourself. All right, so looking at what we've got, I don't see any hands, so I'm going to turn to the chat. So first up, we have a comment here. Meredith's presentation is interesting. Considering the venting system for the houses, what sort of ambient outdoor air monitoring takes place? Are we transferring exposure? What about nuisance odors? And are there any airborne permits required?
So for the system that we have on the sites, you can have either a passive system or an active system. But neither one of those systems are actually extracting any vapors from out of the ground. So as I noted in my conceptual site model slide, you have those vapors naturally just come up from the groundwater and they want to move to an area of lower pressure. And so they come out of the ground. So this is just something that's occurring all the time, but they are at, even if you have a high source down below, they're going to be coming out of the ground very slowly, low concentrations, and into ambient air. So you're not creating any extra issue from that. But where you can have an issue is where if they build up below a building slab and those slabs are large enough and then from there they can migrate into your building. So this system is simply just a system of pipes that let that travel out laterally out as they would naturally anywhere else. So there are no permits that are needed for this. There are no odors associated it. We're not transferring exposure at all. And even if you have a system has to go active, again, that's still not pulling anything out of the ground. It's just blowing it out the sides and helping it go a little faster. Anytime we do vapor extraction, like a soil vapor extraction where we're actually pulling out vapors to clean it up, yes, in that case we have permits and we treat that with carbon before we release it to the air so that we are not creating an issue.
Great, thank you very much. All right, next question. What was, I believe this CG is cleanup goal for PCE in soil gas, and what attenuation factor was it based on?
Yeah, this is CY. I can take this one. Thanks, Javier, for raising another good question. The cleanup goal, when the removal action work plan was approved, which was 2013, I believe, or around that time. Well, we're using the DTAC D4 attenuation factor of 0.001 for residential development, and that remained to be cleanup goal for both projects because both existing residential development and in the future the the former dry cleaner site. I think the goal is again to meet the unrestricted closure criteria. So with that say, we also look at different attenuation factor because for onsite we have the upper barrier probes and lower barrier probes, and for the upper we actually use at the time again it was actually even more stringent than the 0.03 that currently the guidance and the supplemental guidance recommend. DTAC at the time is 0.05. So for upper probe, that was attenuation factor we look at, and then the lower probe, like I mentioned, is a 0.01. And then we look at kind of a different risk target that Jessica mentioned, and next case study also going to illustrate. as far as supporting the risk management decision. And then those are the action level for the mitigation system. And during this upcoming 5-year review that Meredith mentioned, we're also going to revisit these decision criteria to make sure they're still protective.
Thank you, CY. Much appreciated. All right, I do see that we have a hand up. Ms. LaDonna Williams, let me go ahead and click on that. So you should be able to unmute yourself. Please state your name and your affiliation.
Yes, LaDonna Williams. I'm with All Positives Possible in the Bay Area. So my question would be, and I think I heard before because I kept getting some breaks and bleeps in between, that they said they wanted the questions specific to the site and presentation. Did I hear that correctly?
I think that was one of the responses in the chat. That might have been Ben Stanfill, if you are available to come off of mute.
Well,
Okay, so I haven't really asked my question yet. I was kind of clarifying it because what I wanted to ask was, since I'm not real familiar with the site, I did ask Mr. Ben what were sites that the agencies, DTSC and or the water board, since they work partnering together, what sites have these agencies requested relocation for when these residents have been exposed to, or their health has been compromised and they've been exposed long term to these pollutants that the agencies previously deemed as the site being clean enough to construct housing on. And now these residents have been living for years on this housing only for their lives to be at risk. And he said that he could not, or he would not answer the question in the question box that, for me to reach out privately. My problem with that is that lacks, for me anyway, transparency. We're in this public forum. We're here to get information from responsible agencies, yet they want to, have you ask these questions privately, which it should be and or the participant's choice, because it lacks transparency when our questions aren't answered in this public forum. But I would like to know, with all of the presentations you guys have done, you've made it clear, at least from your point of view, how important community participation is in these processes and early on. Yet, when we do participate and we're sharing our valid health concerns and risks to our lives, you guys move on. You force us to meet this high benchmark or checkbox. Many times it doesn't check it on your end to where it's serious enough to remove people off of these sites that you should have never placed them on to begin with. So my question is, at what point do you realize enough monitoring and take some action? Because the monitoring is just sitting watching the bully beat up on the victim or kill the victim in these cases. At what point do responsible agencies like the Water Board and DTSC finally take action to actually protect the public and the most vulnerable, disadvantaged EJ public's health? At what point do you take action to do that? Thank you.
yeah, and that is a totally fair question and critique. It is very rare for us to actively relocate residents, and in most cases, DTSC and the Water Board actually lack the authority to do so. We have to pair up with the county health department. There are 2 projects that I'm aware of, one in San Diego, where the property owner is next to a former aerospace facility that was redeveloped into a grocery store. And in that case, the property owner of the apartment complex elected to start moving residents out of contaminated out of buildings where the TCE concentrations were above our urgent action levels. DTSC did not order that to happen. It's something that we were considering with the county, but in that case, the property owner started doing it by themselves, so we didn't need to order it. And again, it is very rare. There are other cases where we will, again, typically without ordering someone to move residents, will hold certain uh, apartments or condos open until a mitigation measure has been put in place. And again, part of this is also just not knowing all of those right now because we don't track that as a thing. We can look it up, but actually, I'm not even certain that we can look it up easily, but it's a really complicated question. It's, as you mentioned, a high bar to meet to actually need to relocate residents. It doesn't happen very often, and in most cases, it's not clear that DTSC or the water boards has the legal authority to order relocation specifically. So I'm sorry I can't give better answers on this call, but we can look up more, and I'd encourage you to reach out. I put my email in the chat, and we can have a better discussion on that.
Yeah, I have reached out to you guys and I have been in contact with Mr. McMasters, I think it is, and Sanchez, which we do appreciate them responding. But again, just listening and sitting here for 2 hours and throughout the other presentations as well about protecting, the community or the public's health. And it's like you got to start actually being about it, not talking about it and not making it look good in these presentations and on paper. Because if that's the case, take that language out of these presentations. Because at the end of the day, if I can go to a site and watch not only humans, but animals as well, with these huge tumors and growths coming out of their bodies, that is literally visible to the eye. Yet, when we turn to you all for support, which you should be coming to us, we shouldn't have to keep begging from you all to take a step to protect people's health that you never should have put in harm's way to begin with. And so I encourage, and I appreciate you giving me the time because I know I'm taking up time, but I encourage everybody on this call who is about real health protective measures and holding decisions makers accountable for shortening people's lives through their processes and their decisions. We all need to be pressing on folks because today is my community and tomorrow is yours. Thank you.
Thank you
very much for that. All right, I'm looking through. I see no other hands, so I'm going to go to the chat. And I see that there are several questions being answered right now, so stay tuned for those. And the next one up that I see is Mr. Yoon. Are those disclosures updated over time as conditions change? So looking for, are disclosures updated over time as conditions change?
So I had responded to a comment previously. They asked about disclosures, if there were, if these conditions are disclosed to the purchasers of the condos or residences. And yes, they are. There are absolutely disclosures that there is a required mitigation system at the site that requires monitoring. Are those just, and that does stay with the life of the unit. So if that is sold to somebody else, that goes with it. If the disclosures are updated over time as conditions change, that I'm not as aware of because I am not on the real estate developer side, so I'm not sure how they do the disclosures. I know that if you have a land use covenant that is on your site and you get a no further action letter at some point and you're able to remove that, I would think that you could probably change those disclosures, but I'm not familiar with how that works. Don't know if there is anyone else here who might be.
Yeah, would anybody else like to, there's another follow-up comment to that and says that would be a break in the LUCs. All right, any response to that?
What was the question again?
Oh,
Sorry,
it was a follow-up with what
system
you
up.
had just answered, Meredith, with
Okay.
the disclosures. And this was that as conditions change over time, and just that it seems that there would be a break in the LUCs.
Okay. Well, you can have an LUC removed if your mitigation system is no longer needed and you have no further action. That can be removed. Right? See why it can be removed, I assume. Doesn't have to stay
Yeah,
for the life
yeah,
of
you're wrong with the land. Again, the DTSC only make requirement for the LUC, but the LUC actually have to, basically register with the county and go with the property. That's my understanding.
Understood. All right, thank you. We are at 15 minutes. There are a couple of questions left in the Q&A. Those are being answered as we speak. So let's go ahead and go to the next slide, please. And with that, we'll go ahead and take our next 5-minute break. And if we can come back at 11:15. Looking forward to our next case study, and that will be involving the redevelopment of an open lot by Nicole Fry. And we're started.
All right, welcome back, everyone. We're going to be moving on to the next case study. And I'm Nicole Fry from the San Francisco Bay Regional Water Board, and I'm going to be presenting this open lot redevelopment case closure. So this is one of those less complex sites where we see that, a less complex investigation is sufficient. So starting off with the site history, you can see there was a former gas station in the upper left corner of the site. And so that case was closed in 2018 under the underground storage tank low threat closure policy. We also have a former dry cleaner located in this strip mall on the site. And so they used tetrachloroethylene or PCE at the site and caused an environmental release. There's also a bowling alley at the site. And so there's no releases associated with that bowling alley. Currently, the site is vacant and it's up for a residential redevelopment. And so this case study will primarily focus on that PCE contamination and the vapor intrusion risk. So I'm going to start going over the initial soil and groundwater investigation data. So for simplicity, I'm just showing the PCE data since it is the main chemical of concern. There are some breakdown products we'll see later, but for simplicity, just showing the PCE. So looking at the soil concentrations, we see highest concentrations right next to that former dry cleaning machine with 0.03 milligrams per kilogram. Similar concentrations stepping out near the floor drain in the building. The next sample was in the external drain, and there's a non-detect. And then in that storage area towards the back, 0.01. So limited soil data, they're all below residential screening levels. However, this doesn't really give us a sense of any, if there's a significant source out there that could cause a VI potential. And so we'll look to the soil vapor data for that on the next slide. But first, let's look at the groundwater data. So all of the samples collected at the site were non-detect. So this really shows that that PCE contamination didn't migrate down to groundwater. So this is really just a soil contamination site with some soil vapor, which we'll go over next. So again, for simplicity, just showing the PCE soil vapor concentrations. So starting with our max concentration, so this is in that area of the former dry cleaning machine, and PCE concentrations up to 18,000 micrograms per meter cubed. And so as we step out from that high hit, we see that concentrations drop off pretty quickly, 1 to 2 orders of magnitude. And then as we step out again, we start to see some non-detects on the site to the right. But then as you continue out into the street, the concentrations are still present, still above screening levels. And so we did an initial step out across the street, and we then got some non-detects, and these are all below the commercial screening level. And so that helped us to decide that we didn't need to do further vapor intrusion assessment at the commercial buildings across the street there. And then as we stepped out further down the site, we saw another high hit of 14,000 micrograms per cubic meter of PCE. But similarly as to what we saw above, as you step out, we get pretty big drop off. So this time 2 to 3 orders of magnitude drop off. And then as we step out further down the site, we get to non-detect. And so with this initial data, we get a sense of where there is contamination and how much. And so we can move into our initial vapor intrusion risk assessment. So for the risk assessment, I'm first going to go through the calculations, but I think it's always important to also do an estimation of the size of the release area. And so that can help you really put those numeric values of risk into context for this specific site. And this is important because if you have a high concentration, but it's just located in one corner of a site, that's very different than if you have high concentrations throughout the whole site, right? Very different risk. And so that's why it's important to estimate the release area. So for this risk assessment, I'm just showing a very simple screening level based method for calculating risk. So for the PCE cancer risk, I am showing this equation. So we have our soil gas concentration times a target risk, and then divided by a soil gas cancer screening level. Here I'm showing the ESL, or the environmental screening level. And so for the site, we're going to just use the maximum concentration of 18,000 PCE, multiply that by our target risk of 1 times 10 to the -6, and then divide by the residential ESL of 15. And so this gives us 1 times 10 to the -3 PCE cancer risk. And so if you remember from Jessica's slides on the risk management range, this is, well above that higher end of the risk management range, which was 1 times 10 to the -4. So significant cancer risk. Now for the non-cancer hazard, again, you take the soil gas concentration times a target hazard and then divide by the non-cancer screening level. And so again, the maximum soil gas concentration by the target hazard of 1, and then divided by the non-cancer screening level. And so this gives us a non-cancer hazard of 13. So again, well above that threshold of 1. And so with that, I'll then talk about the estimated release area for this specific site. So we have 2 relatively small estimated release areas. And so I'm basing that off of the fact that we have 2 soil vapor concentrations that are greater than 10,000 micrograms per cubic meter. And we get a 1 to 2 orders of magnitude decrease within a 40-foot radius of those highest concentrations. And then we have relatively low soil concentrations up to 0.03 milligrams per kilogram. I think it's important to note that, for any of these estimates, you want to have an idea of how confident you are in it. And so for this site, I'm going to say there's a medium to low confidence in the estimated release area, given the lower amount of data that we have at this site. So at other sites, you might have a more robust investigation, and you might have a more confidence in where that release area is and how big it is. So next, with that risk assessment, the consultants decided to propose an initial remedial action plan of soil aeration. And so here I'm showing that PCE soil vapor data that we had. And so this is before the soil aeration, and I'm showing in blue the area that they're proposing to dig up basically down to 10 feet, which is just above the groundwater table, and basically take all of that soil and lay it out on tarps and let it air out. And so it's important to note that this was proposed back in 2016, and this is kind of an example of a lessons learned where at similar sites where we see chlorinateds in fine-grained soils like we did at this site, we probably wouldn't accept this remedial action plan based on the results that we're seeing here. So here are the post-soil aeration results. And so in that area of the former dry cleaner, we're really not seeing much of a drop off. The concentrations are basically the same. However, we did see, further down the site where we did have that 14,000 before the aeration that has gone away. And so with that, the consultants updated their remedial plan and now proposed a more targeted excavation shown here in brown. And again, this was down to 10 feet, and this time backfilling with clean soil. And so after that excavation, here are some of the sampling results. So I'll just point out that these are the PCE concentrations in micrograms per kilogram, whereas the results on the previous slide were in milligrams per kilogram for soil. And so for most of the samples, we see that they are non-detect, which was great. However, there were a few that we did see some detections of PCE, and primarily along this western wall of the excavation. And so this is the side closest to the street. And in that area, we had some electrical lines kind of running along the sidewalk on the site. And so that prevented further excavation over in that area. So we do have concentrations. They are below the residential direct contact screening levels, but still present at the site. And so after they backfilled with the clean fill, I'm going to now show the soil vapor sampling results that we got from 3 probes located in that clean fill. And so this time I'm showing both PCE and TCE, or trichloroethylene. And they put the clean fill in and waited about 2 months, and then took the first sampling event, and the results are shown here. So we have PCE up to 2,500 micrograms per meter cubed, and then for TCE up to 420. They were then able to do another event 3 months after the excavation, and concentrations of PCE went up to 6,500 and TCE up to 550. So overall, we are seeing, increasing soil vapor trends. They're rebounding into that clean fill. However, we need more data than just these 3 months to really confirm that equilibrium concentrations have been reached. However, we didn't really expect further increases based on the pre-remediation soil vapor data. So just to remind you, here are the PCE concentrations in the street, and then the concentrations on the site kind of closest to the street. And these are in the areas where we think there might be some residual contamination. And you see in these locations, the max concentration we were getting for PCE was 4,800. And so given that we're already up to 6,500, we weren't really expecting further big increases. And so since the development was ready to move forward, they didn't want to collect more data. We thought that was sufficient to then move on to this post-remedial VI risk assessment. So again, I'm going to go through the calculations to get the numeric values, but to put those numeric values into context, I'm also going to go through a qualitative assessment of the residual vapor source. So first, for the risk assessment, this time I'm going to show 2 different methods. I'm going to start with the screening level method, which is exactly what I've shown what I showed for the initial risk assessment. And so in that initial risk assessment, I did the cancer risk and non-cancer hazard for PCE specifically. And so here I'm going to do it for the cumulative cancer risk and cumulative non-cancer hazard. And so for this, you use those same equations I showed on the previous slides, and you calculate the risk and hazard for each chemical, and then you can add them up and then get the cumulative risk. And so for this site, we're getting a cumulative cancer risk of 4 times 10 to the negative 4. So again, this is greater than that risk management range. And then also for the cumulative cancer hazard, up to 13, well above the hazard threshold of 1. And so at this point, it's important to recognize that the screening level method, it's based on screening levels, and screening levels typically use conservative attenuation factor of 0.03. And so this comes from USCPA's 95th percentile attenuation factor from their 2012 VI study. And so use of this screening levels and this conservative attenuation factor, it makes sense on sites where you are kind of early on in an investigation where you don't have a lot of data, or in situations where you have a lot of uncertainty, or where a lot of lines of evidence are pointing to a higher VI potential. However, as cases move along in the process, we're going to collect more data. We're going to become more certain. And so a lot of times you can use that information about your site to justify using an average or median attenuation factor. And so here for this modified method, I'm going to be using USCPA's 50th percentile median attenuation factor of 0.003. Again, this is also from their 2012 VI database study. And luckily, this 50th percentile 0.003 attenuation factor is exactly one order of magnitude lower than the 0.03 95th percentile attenuation factor. And so that makes this calculation much more simple. You don't have to go back through and recalculate all of the risks using this new attenuation factor. You can just take the constant or the values that we got using the screening level method, and essentially you just move the decimal place over 1. And so that gives you a cumulative cancer risk of 4 times 10 to the negative 5. So now we're within the risk management range. And then a non-cancer hazard of 1.3. So just right at that threshold of 1. And so now to put these values into context for the residual vapor source at the site. So we do have a potential residual soil source below the roadway and next to that electrical line where excavation was not feasible. However, we as I said earlier, we would need more data to really determine whether the soil vapor trends are continuing to go up, or they're going to go down, or they're stable. And that could help us rule out significant soil source. And so just to flesh that out further, the idea is that, we saw some concentrations in that clean fill, and it's just not clear if that's just the residual soil vapor in the street that's just migrating into the clean fill, or if there is an actual soil source in the roadway that will continue to feed that soil vapor contamination. And so that's where, a long-term monitoring could show, if concentrations start decreasing, that could indicate there really isn't a source. But at this site, the residential redevelopment was moving forward. We didn't have time or a desire to, wait for those sampling results. And so the consultants instead proposed to do a vapor intrusion mitigation at building 12. So located here. So there's several residential buildings proposed at the site, but only building 12 is really over that former dry cleaner contamination. And so the mitigation system will be at that building. So now looking at the design of the building and the mitigation system, for building 12, it is designed to have 4 residential units. So 1, 2, 3, 4 here. And looking at the ground floor level of these buildings, kind of towards the upper half of these drawings, there's bedrooms, so a more occupied space. And then on the lower half of these drawings, these are the garages. And then they propose to do a mitigation system that covers the whole footprint of this building. It's called an isolated subslab depressurization system. And so you can see here, there's the clean fill below, and then we have this permeable gravel venting layer that's kind of sandwiched between an upper vapor barrier and a lower vapor barrier. And then we have our slab for the building, and within the gravel venting layer, you have these horizontal pipes that are connected to a fan that will actively suck the vapors out from the building and depressurize the area under the slab. And so the plan was to run the system actively, basically until case closure. And some of the benefits of this design were there's potential for lower long-term monitoring costs because it was going to be run actively. They could use pressure differential measurements, as I'll show on the next few slides, instead of chemical concentration data, so slightly cheaper monitoring. And then also there was no air quality management district permit required since we had this double barrier and we weren't expecting much actual contamination to be sucked out into the atmosphere. So next, I'm just going to go over the startup sampling plan for the building. And so they're proposing to do PCE and TCE concentrations at subslab vapor probes. So these probes are, placed within that gravel layer, starting with location 1 in the first unit, and then location 2, 3, and 4. So we have one subslab probe per unit. And you can see on the drawing that these are run back to a utility closet so that they can collect samples without going into these units for ease of access. We also have soil vapor probes, and these are located below the lower barrier. So this gives us a better sense of what vapors are building up below the slab. And so again, we have one per unit. So location 1, 2, 3, and 4. And so the subslab probes are all kind of located in that upper portion where it was more occupied spaces of the building, whereas the deeper soil vapor probes are spread out to give a better sense of the vapors, building up below the barrier. They are also proposing to do one indoor air sample per unit, and these are going to be co-located with those subslab probe locations. Also going to do 3 outdoor air samples, and these will be around the perimeter of the building. And then vent riser air sampling. And so in addition to the PCTC concentrations, we're going to get vapor pressure differential data. And so that'll be at the subslab probes and then also at the fan inlet. So next, I'm going to just walk you through their long-term monitoring plan. And so the plan has periodic monitoring events where they'll be taking measurements, but also doing observations. And so this will include subslab vapor pressure differential. And so based on the system design, the target is negative 0.1 inches water column or lower. They'll also get the fan inlet vacuum pressure, and the expected range for this is negative 0.1 to negative 0.8 inches water column. They'll visually observe the riser outlet and other equipment for airflow obstructions or damage, and they'll listen to the exhaust fan for sounds indicating a mechanical problem. So the frequency of these events, so for the first year 1 and year 2, they'll have quarterly events, and then moving to semi-annual for years 3 to 5, and then annually after that. And so in addition to the periodic monitoring events, they're also going to have continuous fan inlet pressure differential monitoring. And so this will be continuously monitored, and if the pressure goes greater than that negative 0.1 inches water column that will send a signal to the vendor who will then notify the system operator, and so that we can get the system back up and running. Next, I'm going to go over the funding plan for the long-term operation, maintenance, and monitoring of the system. And so in these plans, it's important to include the site-specific cost estimates for the monitoring costs, in addition to the power costs for the system operation, and also the average regulatory oversight costs. And then the plan should also point out who is responsible for those costs. And for this case, it's going to be the homeowners association, and they will pay those costs out of their annual expense operating budget. The funding plan can also talk about whether financial assurance is needed and what mechanism is used. For this case, we decided that the financial assurance wasn't needed. We made this decision based on, the lower potential for VI that we're seeing at the site based on concentrations and the potential for a lower residual source mass. And also we have a deed restriction on the site that does require the operations, maintenance, and monitoring of the mitigation system. So we thought that was sufficient, that we didn't need a financial assurance plan. So next, the building was built, and now I'm going to show the sampling data that was collected in. So looking at indoor air, basically the PCE and TCE were all non-detect, and then in outdoor also PCE, TCE were non-detect. So that was great to see. Then concurrent with the indoor air and outdoor air, we got some soil vapor data, vent riser air data, and pressure differential data. So first, starting with the subslab probe 1. So again, these are those subslab probes in the gravel layer. We had a PCE concentration of 0.87, and TCE concentration was non-detect, and the pressure differential was negative 0.38. So concentrations well below the residential screening levels, and a good pressure differential, showing that the slab is depressurized in that unit. And so then looking at the other 3 units, we're getting very similar concentrations, showing concentrations below screening levels and good pressure depressurization below each unit. Now looking at the soil vapor probes that are below the lower barrier. At locations 1 and 4, we didn't get sampling results, but if we look at locations 2 and 3, we saw non-detect concentrations for PC and TCE. We also then got the vent riser air data. So we had a PCE concentration of 17.8 and non-detect for TCE, and negative 0.78 pressure differential. So showing good suction in the system, good depressurization. However, given the very low to non-existent or non-detect concentrations of PCE within the subslab and soil vapor probes, it was really surprising to see this concentration of PCE in the vent riser air. And I don't have a good explanation for this. However, I will say that I have seen this at quite a few sites that similarly have low level of contamination at the site, and they put in a mitigation system, and then we have these kind of unexplainable concentrations of PCE. The only thing that I can think is potentially there are low levels of PCE coming from the building materials, but I don't really know that for sure. However, at this site and at other sites where I've seen this, we've been able to look at all of the multiple lines of evidence and, usually show that the system is working correctly and that vapor intrusion isn't occurring. And we did that at this site. And so the buildings were able to get occupied, and we moved on to long-term monitoring. And so they have been doing the long-term monitoring over 2 years. So I'm going to share some of those results from the quarterly monitoring events that we've been doing. So subslab vapor pressure differential, they've remained less than negative 0.3 inches water column. The fan inlet pressure differential also has remained less than negative 0.6 inches water column during each sampling event. And visual inspections, there was no obstructions or damage. Listening to the exhaust fan, there was no indication of mechanical problems. So overall, the systems were working as designed, no issues. However, we did decide to move towards decommissioning these mitigation systems. And so here I'm going to walk you through the monitoring plan that we had to decommission the system. So starting in July 2025, the system was turned off. And then the first monitoring event was in August of 2025. So that's 1 month after the system was shut down in the summer. The next monitoring event was in November 2025, 4 months after the shutdown in the fall. And then the final sampling event was this April 2026, 9 months post shutdown in the spring. And so at each of these monitoring events, we got subslab and soil vapor sampling data that included analysis of PC and TC at all of the subslab probes and at 2 of the 4 soil vapor probes each event. So we made sure that we kind of switched which of the 2 of the probes we were getting so that each probe was sampled at least once over the 3 events. And we did that to limit the costs of these events for the HOA. And then we also had a plan in place to quickly assess the need for system restart if the concentrations significantly increased. And so with that, I'll just walk you through the decommissioning sampling results. And so I'm going to show 3 different concentrations for PCE. And I'm just showing PCE because that's really the only thing we detected. We didn't see any TCE. So the first concentration will be from the startup data. So right after the building was built in 2023, that initial data we got. And then the next concentration will be from that first monitoring event 1 month after the system was shut down in August. And then the final concentration will be the November 25 monitoring event, which is 4 months after the system was off. And so looking at subslab probe 1, we see that during startup, we had a PCE of 0.9 micrograms per cubic meter. And then during the 1 month after shutdown, we had 0.8 micrograms per cubic meter. And then 4 months after shutdown, jumped up to 2.4 micrograms per cubic meter. However, all of these concentrations are well below the residential screening level. And then looking at the other 3 units, we see that concentrations are either similar to or below detection limits. Next, looking at the soil vapor probe data. So this is the soil vapor concentrations below that lowest barrier. So at location 1, we didn't get data during startup or 1 month after shutdown, but 4 months after shutdown, we did see 34 micrograms per cubic meter of PCE. So this is roughly, 2 times the residential ESL. But then at all of the other units, we're seeing that concentrations really are similar to detection limits or below detection limits. So not seeing much. And so the last sampling event was in April last month. And so we should be getting those results soon. That sample is 9 months after the system was shut down. We're really expecting that concentrations would fully have rebounded by that point, and we're really not expecting any huge increases. And so taking that information with all of the lines of evidence at the site, we are moving towards case closure. And so to help you see that, I will walk you through this multiple lines of evidence evaluation. So on the left in white, I'm showing the lines of evidence that I thought were important for this site. And then I'm showing on the right here higher VI potential or higher uncertainty scenarios for each line of evidence. And then in green on the left here, that's the lower VI potential or lower uncertainty scenarios for each line of evidence. And so we'll walk through each of these and see where we land for this site. So for site history, we have a pretty detailed site history for the site. And so I'm putting the X over in this green area, indicating a more detailed site history. For site characterization, I put the mark a little bit back towards the incomplete side. And this is mainly just because this is one of those sites where, we do have a less robust investigation data. Um, However, that was sufficient for this site, as we will see. For residual soil source mass, I'm showing the mark here. Based on the concentrations that we're seeing, we really don't think that there is residual source mass here at the site. However, because of that, a little bit less robust sampling data, I'm moving it a little bit more back towards the middle, this mark. For proximity to source, the potential remaining source is very close to that building, so I'm putting it on the higher VI potential side. For the non-aqueous phase, there isn't any at the site, so that gives a lower VI potential. For environmental persistence, I'm showing that in the middle. And so that is anytime you have a chlorinated solvent in a fine-grained soil like we do at the site, it will be persistent. However, because we do suspect there really isn't much source left, we're expecting that the concentrations in soil vapor to dissipate pretty readily. For groundwater plume, we don't have one at the site. So that is lower VI potential. Indoor air concentrations during the startup sampling, we saw all non-detect. That was great. For subslab concentrations, those are all have been, stable, basically below screening levels. For the soil vapor below that lowest barrier, we do have that concentration that's roughly 2 times the residential screening level. And so that that is above a screening level. So I'm showing it in the middle because it's above a screening level, but we don't, it's just that one location, and we don't really feel like there's much mass contributing to it. So it's kind of in the middle. For preferential pathways, we don't really think there are preferential pathways because we know pretty well where any remaining sources are, and we've been able to ensure that preferential pathways don't exist in this new building. For the foundation integrity, all foundations have the potential to change over time. And so that's why I'm showing it a little bit back towards the right. However, this is a new building, and it's not expected that the changes in that building, given the site as a whole, will significantly increase the VI risk. And then offsite impacts. And so as we showed before, we didn't have any soil vapor above screening levels offsite. And so taking all these lines of evidence together, we can see that, not every mark is in the green, low VI potential, low uncertainty range, but the majority are. And so we can use this to justify moving towards case closure. And so hopefully this gives you a way to look at sites, specifically those with concentrations above a screening level, where you want to use multiple lines of evidence to show low VI potential and move towards case closure. With that, we'll move towards questions. And I am going to stop sharing.
Excellent. Thank you, Nicole. And yes, we will be moving on to the Q&A portion for case study number 2. We'll have 15 minutes. Nicole, thank you so much for that presentation. Same rules as last time, everybody. Please go ahead and raise your hand if you would like to ask a verbal question. We've got a lot in the chat that I'll start reading off. I don't see any hands up right now. And just a reminder, instructions are on the screen. Phone users *9 to raise your hand and *6 to mute and unmute. All right, so Nicole, First question up was there a sand layer above the upper vapor barrier and below the concrete slab?
You know, this is where I don't have the details at all fresh in my mind about that mitigation system. But you could email me and I could look it up for you. Um,
Sounds good. Thank
about
you.
that. Yeah.
Not a problem. All right. And so let's see. Next one was, could the soil aeration redistribute the VOCs in soil and soil vapor? Noticed a detection of 13,000 micrograms per meter cubed in a spot that was lower before the aeration.
Yeah, I definitely think, they took that soil and laid it out, and so they definitely redistributed it. Um, but because we didn't see a big drop off, I think, it would have been to their benefit to just do more targeted excavation from the start, putting the clean fill in versus going through this whole process of, trying to aerate and redistributing the contamination within that excavation area.
Gotcha. Thank you. So next up is, hi, Nicole. Can you share what the technical justification was for the use of the median attenuation factor of, this says 0.003, but maybe that was supposed to be 0.03?
No, I think the
0.003.
median is 0.003.
Mhm.
Yeah. And so this is basically what I was saying, that the 0.03, the 95th percentile that we use in the screening levels, that makes sense at sites, early on in the process where we don't have a lot of information. There's maybe some uncertainty. However, at this site, we had, you know, gotten a lot more information. We had done a big excavation. And so at that point, I think it is justified to use an average or median value versus this higher 95th percentile value. However, at a site where there's more uncertainty or other lines of evidence, showing that there might be this higher VI potential, maybe you wouldn't justify it. But at this case, it felt like there were multiple lines pointing to lower VI potential. And so I felt comfortable using like a more median value.
Great, thank you for that explanation. Next up, I do see a hand is raised. Let me go ahead and open that up for unmuting. All right, Steve Lewis, you are able to unmute yourself at this time. Please go ahead and just restate your name and your affiliation. Mr. Steve Lewis?
Yes, thank you. And thank you, Nicole. That was a good case study for all of us who spent a lot of time in the trenches. And I think your presentation regarding the multiple lines of evidence was very helpful. I was wondering if you could just elaborate a little bit in how the multiple lines of evidence give you comfort, because I think at the end of the day, we all need to be comfortable with the bases for our decisions.
Yeah.
Yeah, they seem, and I guess I don't want to go off on a tangent here on this call, but oftentimes we talk about multiple lines of evidence as if they were separate and unrelated to one another. But
Mhm.
we know that they help us put together a picture, a mental image in our minds. And it's that image that gives us confidence or lack thereof when we make decisions. So I was just hoping you could elaborate on that a little bit and share with us your thought process. I think you did a pretty good job so far. I was just hoping to tease a little bit more information out of you.
Yeah. I mean, yeah, I think you really have to do multiple lines of evidence evaluation at a site. I think anytime you have someone saying the cancer risk is above the risk management range, therefore you must do X. That's not a full thought, right? Like you can't justify that because that one cancer risk could be based on on a very, very small amount of contamination that really doesn't have enough mass or force to really cause a risk at any building. And so we have to be careful with those numeric values and really put it into context with these multiple lines of evidence. Um, and so, yeah, I think, like I was saying before too, also, I on that last slide, I showed the multiple lines of evidence evaluation going through the different lines of evidence, but the one that I talked about earlier was the estimation of your source area. And I think that's kind of a hard and it's kind of a squishy thing to do, but you saw that I kind of did a method where, you kind of look at what are the concentrations, how do they drop off as you step out in a certain area. And that can give you, that a little bit of comfort that there is maybe just a little bit of contamination, so not much source, or, maybe not enough to cause real flux into a building. Or on the other side, when you see a really big area, right, that can push you to the other end to say, hey, we have a lot of uncertainty, we have a lot of mass, we need to add a lot more things to prevent that risk. So it can go both ways, really. I don't know if that fully does
Yeah,
it.
no, thank you.
Mhm.
Actually, that was one aspect of your presentation I found most intriguing because as a risk assessor,
Mhm.
when I put on my risk assessor hat, one of the things I recognize is that oftentimes we're focused on the maximum concentration. And your comment about the source area provides an alternative way, and I think more of a common sense way of thinking about sample results. Um, I don't want to put words into your mouth here. I recognize risk assessment approaches are pretty well codified, but that was an aspect of your presentation that I thought was interesting, and I think I'm glad you brought it up again because that was my impression as well. It's just from kind of a common sense point of view. Yeah, thank you.
Yeah, thanks.
All right, great. Thank you for your question, Steve, and your response to Nicole. Next up, I have I didn't quite catch how the risk values changed significantly while the soil vapor numbers were similar pre and post excavation. Did you use a different attenuation factor in that calculation?
So this actually just hammers home the point that, like, when you are using max concentrations, as I did in those calculations, I wasn't using averages, I was just using the max concentration. And I guess the other thing was that initially I was just showing PCE by itself. And then after the remediation, I was showing the cumulative risk. So I was adding in TCE, and I think there was some CIS, some other breakdown products that got added in. So that also could be, why the concentration didn't seem to go down as much, even though we know that we removed, all of the mass essentially. And so again, just pointing out why it's important to not just look at that numeric value when you're doing these risk assessments.
Great, thank you. Next question is, how was it determined that VIMs were limited to certain buildings?
This was purely based on the soil vapor plume, and concentrations weren't greater than screening levels in the areas of the other buildings. So really the only concentrations above screening levels were, in the area of that building 12.
All right, thank you. Let's see. So, a couple other questions here. One question was the VIMS operating in active mode before decommission?
Yeah, so it ran in active mode basically from the time the building was occupied, and then over those first 2 years. And then, you know, for me, like I kind of when I saw the first startup results where we didn't see any concentrations essentially below that lowest barrier, at that point I was like, well, maybe we should decommission, look towards decommissioning the system right now. Because we're not seeing any concentrations. But the developers wanted to move forward, get people moved into the buildings, and so we went forward with the long-term monitoring for those 2 years with the system active, and then we turned the system off, and then did the basically 9 months of post-shutdown monitoring to demonstrate that essentially the mitigation system was no longer needed.
Gotcha. Thank you. And I do just want to note we are almost at the end of our Q&A time. I will ask one more question. There's a couple more in the chat that'll be there for you, Nicole, afterwards. But last one I'll ask is the modified attenuation factor method widely used? And can you share references on it?
So I don't know how many people actually use it, but we do reference it in the supplemental VI vapor intrusion guidance, the draft final. Well, I'm forgetting the year of that. Um, so that it is in there. Um, and so you can find those equations in that guidance.
Yeah, just really quick. DTAC also allow like a range of AF, on a site-specific basis. So yeah, I guess it's site-specific.
Okay, awesome. Thank you so much for those answers. And so, yep, it looks like there's one last question in the chat. We'll go ahead, Nicole or other members of the team can go ahead and answer that one. And we'll go ahead and move to the next slide, please, and we'll get to our lunch break. Thank you again, Nicole. Really appreciate it. All right, everyone, lunchtime. We greatly appreciated you sticking with us and engaging with us throughout the morning. We will please stay on the Zoom call. Please leave it open during your lunch break. If you close it and rejoin after lunch, you won't be able to see the previous chat messages nor the previous questions in the Q&A. So we do recommend that you leave Zoom on. So as a reminder, the afternoon session will feature the Vapor Intrusion Partner Panel, followed by an open 30-minute Q&A. The partner panel participants include Eric Shavira from City of Anaheim and Meredith Church from Verdantis, who we heard from earlier in the first case study, Tom Graff of GraphCon, and Jonathan Sanders of Clean Vapor. The group will be discussing the 4 topics, including experiences with homeowner associations and community members, when to start considering cleanup needs and redevelopment endpoints, cleanup planning for affordable housing, and closure and long-term risk management decision-making. It's all about collaboration, innovation, and the real-world experiences. And with that, have a great lunch, caffeinate, and we'll see you back here at 12:35. Thank you very much. All right. Hello, everyone. Welcome back. Good afternoon. I hope everyone had a great lunch. Welcome to our Vapor Intrusion Partner Panel. We're very excited to have you with us for this discussion. And again, today's panel is all about collaboration, innovation, and hearing real-world experiences from our industry partners. Joining us today for this discussion are Eric Shavira of the City of Anaheim, Jonathan Sanders of Clean Vapor, Meredith Church of Verdantis, and Tom Graff of GraphCon. Panelists, please go ahead and turn on your cameras. All right, excellent. And so before we dive in, I'm going to go ahead and give some brief bios before we dive into our topics. So Mr. Shavira has an MBA from California State University, Fullerton, and is a project manager with the City of Anaheim's Housing and Community Development Department. He supports affordable housing projects and focuses on advancing initiatives in coordination with regulatory requirements and community priorities. Mr. Sanders is a licensed civil engineer with 13 years of industry experience and 5 years of experience as a regulator at the Alameda County Environmental Health Department. He specializes in vapor intrusion mitigation and remedial system design and currently serves as the Vice President of Clean Vapor, overseeing West Coast operations from San Ramon. Ms. Church is a professional geologist with over 20 years of managing geologic, hydrogeologic, geochemical, and hazardous waste investigations. She has supervised all aspects of environmental assessment investigations, including drilling soil borings, installing groundwater monitoring wells, oversight of underground storage tank removals, and associated remedial excavations. She has also managed numerous Phase 1 and Phase 2 environmental site assessments, as well as the design, installation, operation, and maintenance of various remediation systems utilizing vapor extraction. And finally, we have Mr. Graff. Mr. Graff has a Master's of Science from Stanford in Geotechnical Engineering and conducts a broad range of civil, environmental, and geotechnical engineering and hazardous waste management services. His project responsibilities include strategic input and/or management for consultant selection, review of environmental scopes and strategies, and management of regulatory agency meetings and negotiations. Next slide, please. All right. So once again, let's go ahead and I invite our panel partners to go ahead and turn on your cameras. Thank you so much. So for our first topic, this one is going to center on homeowner associations or HOAs and community members. What are your experiences with working with HOAs or community members? What roles do HOAs and community members play? And what challenges and successes have you seen? Meredith, would you like to kick this off?
Yeah, Julie, this is a perfect one for me because I have several HOAs that I work with. And my experience working with them has been, I have transitioned, it's been a nice smooth transition from the consultant that worked on the site doing the assessment to then doing the monitoring for that HOA, which is really good because we're familiar with the site and all the requirements on there. And the HOA has a very important role, obviously, in the community of making sure that, keeping the community safe, making sure that any requirements in land use covenants are followed, making sure the house colors are pretty, right? But all those things are really important. And especially with any requirements that are regulatory, it's very important that they're, one, aware of those, and two, knows what needs to be done and engage with the consultant to do that. There's also often a property management company that's involved with the HOA. So generally how I work between them is that I'm aware of the monitoring schedule, what the requirements are, and so I send a proposal out every year to the project management company. And then I let them know, like, look, make sure that this gets in front of the board at the right time so that they can get it approved, or let me know if they have any questions. And then when that's approved, we can continue to do our monitoring. And that's generally a relatively smooth process, and the HOA plays an important role in then distributing the information to the community as well. Now, what you have happen sometimes, and this is a challenge, is that you can have a turnover of your HOA. Sometimes you don't just lose one president. I've had it happen before where there's almost an entire turnover in your HOA members, especially if it's the president as well. And your property management company, yeah, they kind of know what is going on, but honestly, they really aren't that informed either. And in my experience, haven't been super great at like managing things. It's really that you're a consultant and your regulator. So then they've come and I send in my proposal and they're like, well, what is this? What's happening? They don't understand what it is or why they're doing it. And so as I noted in my previous presentation, I get some of these big questions of why are we doing this, et cetera, et cetera. So that's when I've let my HOA members know, like, look, I am more than happy to have a meeting with you at any point, whether it be virtual or I've even actually had in-person meetings as well, get to know them, let them know the background so that they really have an understanding of what that is. Because, that's a definite challenge for your HOA and your community members, because sometimes you have a community member, maybe they're not on the HOA, but they really want to be informed and have questions as well. Another big challenge that we can have on sites is getting access. So the monitoring locations at a house can vary in their location. I've seen some houses that have had their monitoring points actually in their backyard. So it's kind of like having someone who do lawn care, right? You've got to open the back gate, make sure your dog's put away. Well, we've had those kind of same types of challenges. A lot of times they're on the side of the house, which is a little bit more accessible. But still, we want to make sure to give those proper notifications that we're going to be on site. And that also has been a challenge. Let me give you an example of a site that I was working on where we thought our notifications were getting done properly and that the HOA or to the property management company, and they were letting the HOA and all the community residents know we were coming. And in fact, we learned later that that was not happening. And we learned this when there had been a break-in in the community. So all the community members were on high alert. And then when my staff went to go do the regular routine quarterly monitoring, they're like, wait, we think we've seen her here before, but is she the robber maybe? And it also just happened to be very unfortunate that she had got out, was checking out the ports and had not put on her vest and looking all official. We just use our own cars for the monitoring. So the community members were very alarmed. The police were called, and that's a lesson that you learn between of communicating with your property management company, your community members. Yeah, obviously we got everything ironed out. We've made sure that all of our staff put their PP on immediately, have business cards. We actually have a magnet now we put on our car so that we're transparent. But that's just a big example of a challenge. And that has been turned into a success since then because we now have a much more seamless process. The community is more aware of what we're doing and why we're there. The other big success is just having these meetings with the community where we can go and educate them about what we're doing and why. And then they're like, oh, okay, we get that. Doesn't mean you like having to do it, but you understand the process. And so that's been a big success as well. So those are some of my experiences. I'll hand it over to see if anyone else has any other input they'd like to add in as well.
Yeah, this is Tom Graff. I definitely echo what Meredith has been saying with HOAs. One of the primary things is communication. For me, it's been kind of in two parallel paths, is that you've got the HOAs that are over a source property, but you also have HOAs where contamination is migrated underneath their property. And again, I think it's to get people to understand, and this is tapping them on the shoulder, the properties that have the migration, is investigation, maybe some remedial installations. So, and you have to assume that the HOA folks don't have any idea of what the chemicals are or the language that we use in describing things. So I think it's real important to initially really sit down, explain to people what's going on, let them know what the benefits are and that sort of thing, and what it's going to take to participate in doing. But again, I think the communication to people that don't typically understand our field is really important.
Yeah, thank you both so much. Really appreciate your thoughts on this. I'm going to go ahead and move us on to the next topic. So next slide, please. So the second topic for discussion focuses on cleanup and redevelopment endpoints. So general questions here are, when do you start considering the cleanup or redevelopment endpoint? How does your chosen endpoint guide your approach to cleanup? What are your top priorities? And how do different agency approaches influence projects? Tom, would you like to get us underway?
Yeah, this is Tom Graff. The consideration of the endpoints on a project should really begin early with the completion of the phase 1 and the initial phase 2 investigations. The full site investigation may not be completed, but once you have a fundamental understanding of site contamination, that should be enough to discuss how it impacts remediation and development options. In California, the approach, timing, costs, feasibility, all those are consistently different within the various regulatory agencies. So because both schedule and costs are linked, meeting the regulatory agency timeframe up front to agree on the overall approach is needed to understand cleanup, development, redevelopment parameters. And this would be agreement on the evaluation of risk, use of screening levels, attenuation assumptions, mitigation versus remediation requirements. That's all essential in understanding the scope, the timing, and the feasibility of a future proposed land use. The best way to prep for this initial meeting is to decide how you want to approach the site. And this is prior to this meeting, the timing, remediation, mitigation alternatives. What are the financing requirements, use of land use covenants or not? In some cases, based on this preliminary internal discussion, it'll be apparent that the assumed financial requirements for the development concept for a site may need to be reevaluated, or the project may not even be feasible. I currently have a site with DTSC that likely will not move forward after a couple of years of investigations. And if we had this concept meeting earlier on in the process, it would have saved a couple $100,000 in investigation and agency costs and time. So for the water board, typically an initial meeting with a case manager and their supervisor is sufficient to understand the scope of requirements and considerations. For sites with more complicated parameters, inviting the toxicology reviewer from the water board can help focus this discussion. In my experience recently, the San Francisco Regional Board has been open to working back and forth to develop and refine requirements on a collaborative basis. For DTSC, where there's a multi-layered review process, having an upfront meeting to define the management, team members, and goals is recommended to guide the individual DTSC reviewers on their data reviewing and reporting. Again, the site owner, developer, consultant team should have thought through the site parameters prior to this meeting. One goal is to get all the members of the DTSC team to be from the same office so they can agree on the overall approach and discuss issues internally prior to issuing individual guidance responses and putting things in writing. The DTSC review team typically includes case manager, geology reviewer, engineering reviewer, toxicology reviewer, and a supervisor. So agreeing on a path forward that all of the individual reviewers will follow reduces staff time, it reduces the differences in the individual approach and costs. This is something that DTSC is currently working to refine in their offices. Based on my experience with county health agencies, these meetings are really important to understand how they use state and federal guidance in managing environmental aspects of site development. In the Bay Area, for example, San Mateo County follows water board and DTSC guidance for most parameters and can be relied on to evaluate residual chemicals on a site-specific basis. They incorporate, for example, the petroleum low threat closure criteria for all sites rather than just underground storage tank sites. However, they don't use the DTSC water board consideration of 1 × 10⁻⁵, for example, for commercial risk characterization. They only use the 1 × 10⁻⁶. In Santa Clara County, they use screening levels as the required cleanup concentrations and do not typically consider site-specific evaluation. They don't consider the petroleum low threat criteria for non-UST sites, and they use screening levels very often without consideration of biodegradation. And again, this is important for understanding where you need to go on a site in collaborating, with the agencies. For Alameda County, they've maintained quite often that the water board and TTSC are not doing enough on managing sites. They are requiring both investigation and remedial measures that would not be required by either of the state agencies. These differences are something that state agencies are trying to address with meetings and education opportunities for the counties. For site cleanup considerations, future site use alternatives can provide a basis for the cleanup and long-term management options. As discussed in this whole holistic approach series, use of multiple lines of evidence can focus cost and time-efficient approaches. Many agency and staff consultants use screening levels without consideration of site-specific parameters, which include construction type, soil permeability, potential for natural attenuation, expected efficiency of recommended remediation or mitigation methods, and actual exposure pathways. For example, using an appropriate attenuation factor for a post-tension 12-inch thick floor slab rather than the generic 0.03 can allow many sites to proceed without significant regulatory input. Requirements for future residential use without a land use covenant can be significantly more extensive than development with a land use covenant. Also, if a land use covenant is being considered, the cost of long-term O&M and regulatory reporting, in addition to DTSC 30-year bonding, for example, need to be discussed early in the process. And again, as we talk about the differences, the flexibility of agencies needs to be understood. The Water Board regularly considers closure with M&A for groundwater and vapors within an extended time period, where DTSC often requires remediation to require concentrations prior to closure. So upfront discussions on soil vapor and groundwater cleanup with the Water Board can result in target remedial concentrations above MCLs and above vapor screening levels. Use of screening levels is more than a starting point, can create overly conservative approaches for site remediation and mitigation. For sites that have impact beyond property boundaries, as groundwater or soil vapor migrate, the agencies often allow parallel closure pathways for on-site and off-site impacts. This can allow no further active remediation and development of the on-site portion of a site or source site with long-term remediation monitoring of off-site impacts for groundwater and soil vapor. So in sum, early consideration of environmental and community impacts to site remediation and development can save significant time and cost for projects. Collaboration with the agencies rather than just checking the boxes will serve to improve approaches, understanding, timing, and costs. Thank you.
Great, thank you. I was curious. Yeah, any other
I
thoughts
can
out there?
add in if there's time. I don't know how
Yes.
we're doing for time, but I think Tom, you hit a lot of the key points right on the head. I think that I agree that essentially the planning for these things needs to happen way at the front. And one of the big issues that we run into often is making these decisions too late and then being kind of stuck with with less outcome certainty and fewer options. And something I kind of want to highlight on a lot of this decision, the question of when you start considering these your endpoints, a lot of that comes down to the fact that at the end of the day, we're all trying to get redevelopment to happen. I think collectively, as a set of regulators, consultants, and all of our clients, we all kind of recognize that in general, the revitalization and development of these brownfield sites is good. And in a lot of ways, it's the only way that remediation is going to happen, right? You can have a very recalcitrant responsible party that all of a sudden when money is going to change hands and it's time for a developer to come in, it's the thing that motivates them to actually come to the table and do cleanup. And a lot of the time that we're looking at these endpoints and these decisions, it is that balancing act as consultants of how do we do the greatest amount of good while still making this a viable redevelopment project, right? And we have to balance the viability of the project, because if we go chasing the, the golden solution that fixes all problems, sometimes that can be cost prohibitive to the point where nothing's going to happen because no redevelopment will occur because it's not feasible for the developer to act on that. And kind of on that same topic, I think a lot of the times we need to consider the different stakeholders at the different points in time when we're considering these endpoints, right? The endpoint for your client, the developer, may be different than the endpoint for the client or whoever is selling the property. And it's going to be different for the lender, or if there's financial institutions that are providing grants or bonds or anything else. They all have their own requirements, and there's specific dates you have to hit. There's specific things you need to be able to achieve, and you want to make sure you don't set yourself up for failure early on in that project. I think kind of the last kind of comment where Tom was mentioning the discrepancy between different agencies and how the agencies approach things. And it's very true. I think we all intuitively know this, that every agency has its own feel. And there's things that certain agencies are more nimble on. There's things that other agencies are more nimble on. Understanding the regulatory environment and knowing where your client's going to have the most success is an important part of our job. And with some agencies, right, they can be more responsive, but they have less technical acumen. And so you need to acknowledge and recognize that you might not be able to make as technically savvy an argument with some regulators that you will with others. And there's that balance between what's the complexity necessary to get the developer or your client to the end goal and to satisfy whatever regulatory oversight agencies requirements are. So I hope that helps.
Great. Thank you very much, both Tom and Jonathan. Thank you. All right, looking at the time, I'm going to go ahead and move us on to the next topic. Next slide, please. So for our third topic, this is one of the most common that we've received comments on, is the cleanup planning for affordable housing. So the question here is, what are key considerations for municipalities when integrating environmental cleanup requirements into the planning and implementation of affordable housing projects on contaminated or previously impacted sites? And then Eric, would you like to kick us off?
Sure thing. So I think it's important to understand kind of how the City of Anaheim Housing Authority get their sites prepped for development. So typically what happens is we have a site that, has some impacts. We look to remediate the site as best as we can so that when we do put out an RFP to developers, the site's clean and they're ready to be able to build on. However, there's sometimes situations where BIM systems are required or some type of system that's required after or before the project is built. So that essentially be the burden of the developer to implement. Really, as far as cleanup goes, we're kind of done once the RFP is in the hands of the developer and the developer is kind of building up the construction. And so they would be responsible for that. But again, that doesn't always happen. Sometimes there's situations where, sites, there's still some additional delays or situations happen where the site isn't necessarily clean. And now we're working with the developer and we're trying to clean up the site. And a recent example is on a project that it's currently under construction where we had the site was, we had the developer on board. We had some environmental cleanup work going on, and the developer had already applied for tax credits. And so now we're kind of trying to deal with these timelines of getting the project started with construction and having to get the site cleaned. And we work with DTSC on this side, and shout out to the DTSC team that helped kind of push this project along. Fortunately for that project, we were able to, get the no further action to be able to build on the site and now it's currently under construction. So, sometimes there's some adjustments that need to be made to be able to get to that point. And not every project is the same, as we all may know. But just to kind of further get into the key considerations, conducting environmental testing early to understand contamination risks and cleanup needs is crucial. Really, it starts with the phase 1, and then from there you get to the phase 2. So really getting an understanding, and at the same time making sure that developers that are potentially building the affordable housing are aware, and that could be through providing language within the RFP so that they're aware of the certain issues that the site may have. Another one is ensuring cleanup standards match residential use, especially because affordable housing often serves families and sensitive populations. And knowing that, the sites that we're building are slated for affordable housing, we're going to have the strictest level of cleanup. And so really taking that into consideration is key as well, as far as planning for the construction of whatever BIM system needs to be built, but also on the financial side, if there's additional costs that need to be incurred to be able to get those systems in place. Coordinating early with DTSC and other regulatory agencies to avoid delays and conflicting requirements. Really touching, hopefully you have someone that you can contact within the regulatory agency that you might be working with, that you could reach out and maybe get things started, and just maybe getting an idea of what might be required. The DTSC team that I work with, they're very open, and I'm able to reach out to them and ask them questions. So coordinating early is key as well. Integrating cleanup measures into project design and construction planning from the beginning. And this goes back to, when we're designing the plans for the project, making sure the developers are aware of, what needs to be integrated into the project design. And then accounting for cleanup costs in the project budget, and identifying available grants and incentives and affordable housing funding sources. And this is, as I had mentioned in the case, we're constantly searching for new funding sources to be able to get these sites cleaned. And whether that's a collaboration between us and the developer to help get those fundings to be able to build the sites, because ultimately the goal is to build more affordable housing. It's finding that money to do so. Maintaining a clear project timeline, since environmental review and remediation can affect affordable housing financing deadlines. And this goes back to that previous example. A lot of our sites have tax credit requirements that are, have strict timeline deadlines that need to be met. So really understanding what those timelines are, especially from the early end, whether we even go out to RFP, maybe we hold off until we know that the site's gonna have a clear timeline. And going back to the case, the source site, we understand that site's gonna take a while before we're able to get to the point where we have a developer on board. And so, at this moment, there's no plans to even put an RFP out, but we're constantly thinking about the future and how we could help develop the sites. And then engaging the community early and transparently to build trust and address environmental justice concerns. I touched on this in the case. The community is key as far as getting their feedback, making sure that they're aware of the certain situations. We've run into issues where, residents have had concerns and they bring it up to the city council. So we can get to them before these concerns are made to the city council. We avoid having maybe a misunderstanding, and we're able to potentially answer some of those questions before we get to, the city council side or more public in that aspect. And then planning for long-term monitoring or maintenance if engineering controls or land use restrictions are required after construction. So if there's a VIM system that needs to be monitored on a quarterly, biannually, annually basis, making sure that that's being considered as far as budgeting goes and financing, and also relaying that information to the future tenants that'll be living there, making sure that they're aware of those issues. And the systems that are currently in place. And then balancing the need for new affordable housing with long-term public health benefit. This goes back to, trying to build as much housing, but also being safe at the same time. And then using redevelopment of impacted sites as an opportunity to revitalize underused properties and improve community conditions. A lot of the times, specifically with that source site, we knew that the owner, probably didn't have the funding to be able to clean the site up. So, the city took the initiative to acquire the site, and, we're able to move forward through kind of our resources of being able to apply for certain grants to be able to get the sites cleaned up. So really looking at opportunities where there might be a site that might be vacant and potentially reaching out to the owners to see, what the plans are, so that we could build more affordable housing. And if any other panelists have anything to add, feel free to chime in.
I can chime in. So a couple other things. Eric had mentioned the requirements of your different lenders or your grants or whatever. And I want to kind of tease that out a little bit. The big things that you got to worry about when you look at the contracts for these grants or these funding mechanisms are that there will be requirements for when you have to hit certain critical dates. And they're not always the same, but they're usually things like you must start construction, meaning do earthwork, by a certain date. You must have permits in hand by a certain date. You must have occupancy by a certain date. And there's even sometimes things that say you have to have a no further action letter by a certain date. And understanding those requirements for your funding is critical, because some of these mechanisms, if you miss one of those dates, all that funding is forfeit, and it can be millions and millions of dollars. And so when you're working on a project like this, understanding those requirements is critical. There can also be other contract requirements like having union workers or union laborers for specific things, or having prevailing wage. And as a consultant, if you're getting brought in on these, you got to make sure you check those. The last thing you want to do is get brought into a project, think everything's fine, and then you got to pay a bunch of your laborers prevailing wage, or your costs go through the roof because the estimate you got for installation of a vapor mitigation system or drilling of wells now has doubled or tripled because all of your wages have gone up on that. Kind of on that same topic with these requirements for these critical dates, outcome certainty is one of the most valuable things on these projects. Being able to set a time frame, stick with it, and hit it. Much more so than you'll see in a lot of other traditional developments. I mean, obviously, every developer wants to stick to their schedule, but at the end of the day, most developers that aren't using affordable housing funds, if they are off by a couple weeks or they miss some funding, they're carrying some interest, and it hurts their overall profitability. For affordable housing, it's they lose funding, period. And so, early on, and this kind of goes back to what Tom was talking about in the first topic, defining your scope and saying we are doing this much remediation, and we're not going to chase things ad infinitum. We're going to start construction after we get this part done. Negotiating those things with your regulatory oversight agency are paramount to the success of these types of projects. I mentioned it before, no further action, right? There's a big difference between getting a no further action letter and a no further remedial action letter. And one of those is very feasible, and you can negotiate with the regulatory oversight agency if there's any sort of mitigation. That could be, lead encapsulation cells or vapor mitigation systems. They'll say, yeah, no further remedial action, but no further action, period. That's a much bigger lift, because that means there's no long-term monitoring, there's no mitigation. And so being cognizant of what those terms are before you start a project and not getting caught halfway through the project finding out that you're screwed is important. It's also important to consider for these projects who's going to ultimately retain ownership and who will the stakeholders be again. I know I mentioned stakeholders before, but a lot of these long-term or these affordable housing projects, the municipality will retain ownership. A developer will come in and they'll build a certain number of market rate houses, and then they'll also build the affordable housing, and it will be like a 100-year lease or something like that for some of these things. And so the ownership can get more complex on those than you might have for traditional, I'm going to buy this lot, I'm going to build on it, and I'm going to sell on it, okay? Last but not least is occupancy, right? So for those of you that have dealt with building authorities and how well they coordinate with regulatory oversight agencies, you all know that sometimes it's all gravy and smooth. Sometimes it goes great. Other times there is layers of bureaucracy, and you need letters from your regulatory oversight agency to hand to the building authority, but you can't get those letters until super late, and it can cause big delays at the end. And that can run amok with some of these funding mechanisms. And that's where understanding whether you need a temporary certificate of occupancy or a permanent certificate of occupancy can matter. TCOs, usually much easier to get, you got a lot more flexibility, and you have a longer runway to fix whatever edits or comments you get from the regulatory oversight agency so that you can get to PCO, which is a permanent certificate of occupancy. If you have to have PCO, boy, you need to plan for that well in advance, and you need to build it in your schedule. And it's something you really got to talk about with all the stakeholders, because it's the sort of deal where you might end up giving your regulatory oversight agency, 1 or 2 weeks of review time, and that's it. And you got to have everything perfect. And those are the sorts of things that we all stress about and nobody likes. So those are my additional thoughts. But anyone else on the panel have thoughts? I think, Eric, when we had spoken earlier, you'd mentioned that there was a process that the city of Anaheim does to check for contract requirements and things like that.
Yeah, it was just regarding the labor compliance stuff. I mean, we're making sure that the developer knows that all of their contractors, subcontractors are aware of these labor prevailing wage requirements early on in the process. I actually oversee that aspect of the projects as well, labor compliance. And so, really making sure that all of that information is, provided to them and it's clear. And then kind of going back to your point about, whether the municipality actually owns a site or, retaining ownership. We've dealt with that too. A lot of the times our affordable housing sites are on leases. And so with one site in particular, there's a VIM system being installed. And so that technically would be the responsibility of the developer. The reason being is because the developer is overseeing the site, the day-to-day site. And so at that point, the city doesn't really have the ability to, address any issues if the system, if there's, I guess, issues with the system needs to be addressed or something. So just wanted to add those points.
Thanks. And Meredith, I see your head. Sorry, Jonathan.
I just wanted to say one final note. You guys did a fantastic job of summarizing this. And as you can hear, it's a lot more complicated than you would think. So for any municipalities out there who wanting to develop, just make sure that you have these conversations with your consultants ahead of time, and make sure that you select a consultant that is really aware of these timelines and different issues, and they can help navigate you through it a lot.
And one final thought I have that occurred to me while Eric was talking. The other thing you got to watch out for, especially on these affordable housing projects, you might have a large tract of land that realistically has 2 or 3 developers working on it, right? And they're all doing a separate part. And the structure of the regulatory case can matter, because you might have 2 developers that are doing great and they're doing fine. But then you got a third developer that is just dragging their feet. They don't want to cooperate. They want to cause problems. And if you have a single regulatory case as opposed to 3 cases, what happens is your enforcement occurs collectively to all of them. And that's the sort of thing that can invalidate some funding mechanisms. And so particularly if you have like a section that's affordable housing and a section that's market rate housing, it can be really beneficial to all parties to cleave that into 2 separate cases. Having them linked but still being able to enforce on one while not enforcing on the others. So it's another consideration to think about when you've got these larger, more complex sites with multiple stakeholders.
That's super helpful. Thank you so much. I'm going to go ahead and move us on to our fourth topic. So next slide, please. And so our final topic for this partner panel is going to be case closure and long-term risk management decisions. So the question is, how have closure and long-term risk management decisions played into the following areas of a redevelopment plan? The type of redevelopment, such as affordable housing, which we just talked about, or a new park or commercial space, the funding plans, redevelopment timeframes, building occupancy timeframes. As you can all see, this is very linked to the previous topic, but I know there's a lot more to discuss, so let's go ahead and dive in.
I know I've been talking a lot, but I'm gonna talk
Go
some
ahead.
more if there's no objections. So I think that kind of going part and parcel with that very first question: when do you start thinking about these things? When you're thinking about these things, and when you're first beginning to consider your type of development, that's where you're looking at a lot of these elements. And there's going to be some simple things you can look at, like where does your infrastructure go, right? Do I have strategic locations that I can put parking garages or surface parking or stormwater collection or easements, things like that, where maybe my nasty stuff is over here. I'm not going to put my building over there. I'm going to put other infrastructure that I need. There's also, the site use. We're seeing more and more sites where you're having ground floor commercial or residential above, or ground floor commercial with parking on the portion of the first floor and then an air gap on the second floor. Smart building design like that can go a long ways towards mitigating your risk. And it's not just about VI. I know this is a VI focused workshop, but the same concept also applies to other exposure pathways, right? Lead encapsulation cells, PAHs, things like that. There's lots of things that you can leave on site as part of development, so long as you have appropriate engineering controls or appropriate depths of basically encapsulation. And so that can become a really useful tool, again, looking at the viability of these projects. We got to find as an industry viable, financially feasible pathways for these developments to occur, and we got to do the most amount of good with remediation and protection of health that we can while getting to that endpoint. That's ultimately what we're all striving for. There's also a lot of people don't realize how much the schedule it can be driven by the decisions you make about your funding plans and your redevelopment timeframes, right? We're used to having the GC following up with us and being like, hey, I got to do this on this date. I got to have these things. But a lot of times it's easy to forget about, your occupancy and closing schedule, right? You've got forward planning with your developer that's a different entity. It's not your ops division. It's something else. They're trying to figure out when they can sell units, and you got to have all that stuff in mind. You have your lenders that are converting loans. You have closings of homes for sale. You have all these other elements that the funding, whether it is at an operational side or at a purchase side, they all tie in together. Commercial real estate and industrial real estate obviously has its own nuances, right? Those funding mechanisms, especially for those large projects where you're doing like 300,000 square foot warehouse buildings, those types of sites, they have their own requirements, and you got to consider that when you're looking at your planning for this development. And then there's also just the question about you're making these decisions about long-term risk management. We tend to overemphasize as an industry the capital expenditure. We tend to, when we're trying to make these decisions about viability of a project, look about how much is it going to cost to build. And it's easy for us to optimize that cost and forget that my operational expenditures, my OpEx, also does matter. And it can matter more to some proponents than others, right? If I'm a home builder and I'm selling these homes, I only care about it so much that it might affect my financial assurance mechanism, or that if my HOA dues are too high, I might have a hard time selling homes. But outside of that, I don't really care how much it costs you to run the system as long as I can sell. That being said, there is the next phase, right? After the project gets moved away from the developer, you have an HOA that needs to manage this thing, and they do care a lot about that OpEx. So planning those things early on can set you up for long-term success, not just with your current client, but with your future clients as well. And last but not least would be that financial assurance. I mean, we've got this, there's a line item here that's the funding plan. And that applies not just to the funding during construction, which is important and has a lot, that's what we've talked a lot about, but it's also the funding of all this long-term monitoring post-construction. So the classic struggle that a lot of these HOAs have is that an HOA has no credit history. They have no assets other than the buildings themselves. They don't really have a big coffer of money sitting around. And you can easily run afoul of a point where your estimates for cost for long-term monitoring at the beginning of the project maybe don't cover all the costs by the time you get to the end of the project. And so now who pays for that? Right? The developer's trying to leave. And a lot of times they are gone. So what does the HOA do? And that's where planning these things early on, giving yourself those that wiggle room, both in the budgets that you set with the California Board of Real Estate, as well as with your plan for how you're going about monitoring this long term, make a big difference. I'll open it up to anyone else that wants to talk.
Yeah, just to add a few points there, Jonathan, all great points. But so regarding type of redevelopment, for us, unfortunately, we don't have the luxury of just saying, oh, well, let's make this a park instead, just because the sites are owned by the housing authority. And so they're kind of slated for that specific use. And so we have to find a way, find the funding to be able to make those sites, at a standard where we can build housing on there, make them safe enough to be able to build housing. Yeah, regarding funding plans, we deal with this pretty often where, the lenders and investors require some proof of regulatory closure or approved risk management. And so these lenders aren't going to fund any of the projects until, that's been shown to them. And so the developers really, really, push for whether it's the city kind of driving that or themselves, to get that closure so that they can get funded, right? Because without the funding, you can't build a project. And then again, that long-term operation and maintenance obligations that can affect the budget and possibly the financial feasibility. I mean, if the project isn't financially sound, then the project might not happen based off of, some of the issues that might be there. So what that means is you have to, the city either has to search for more funding to be able to address some of those concerns, or, it's a collaboration between the city and the developer to be able to make the project feasible. Regarding redevelopment timelines, the regulatory review, remediation activities, and closure approvals can significantly extend project schedules. And this is huge, especially when we're dealing with tax credits and those timelines. So, add in some buffer time just in case situations arrive, there's additional need, or we have to do resampling. All of those issues can occur and, maybe probably will occur. So make sure you have that buffer time in. And then a way to kind of address that is potentially sequencing some of the cleanup activities with site grading and construction that can help keep the project a little bit more on schedule. And then regarding building occupancy timeframes, buildings generally cannot be occupied until cleanup requirements and health protections are verified and approved by regulatory agencies. And this is, the project has been constructed, and now maybe there's some indoor sampling that needs to be completed. And so that's something that needs to be considered from the developer as far as those timelines that we were discussing, the tax credit timelines. And so, just other things that need to be considered. And then delays in the closure certification or environmental sign-off can directly affect tenant move-in. And that goes back to Jonathan's point about the, TCO versus the completion of occupancy. So, maybe TCO is the route to go to allow a little bit more buffer time. And if there's any punch list items that need to be addressed, you can get there through TCO. And as far as, meeting some of the requirements that the developer or that the funders have. Anyone else has anything to add?
Yeah, this is Tom Graff. Is I was kind of backing up more what you and Jonathan had both said, is that For affordable housing, for example, I've seen another number of projects that just don't have the ability to pay long-term costs. And I have one project a few years ago that people didn't realize that monitoring was going to have to be done when they did the budgets, and they came in and all of a sudden said, where are we going to find this money? And so I think that a lot of in the development plans, the long-term risk management plans for organizations, like say HOAs or affordable projects that don't have a good cash flow, that the long-term monitoring requirements be minimized in developing the whole remedial mitigation plan.
I was going to tack on to that, Tom. You triggered a thought for me, which was the other caution. Be leery of trying to develop a site and clean up a site using LUFT funds and relying on those LUFT funds for anything to do with long-term monitoring. That can be very, very problematic. So if you've got a petroleum site, you're going through redevelopment, you think you got funds for the LUFT, you may be able to use some of those during the cleanup. You may be able to use those to get the NIMS system installed. You're going to have a real hard time clawing those funds out to do any sort of long-term monitoring. And then the last kind of thought I would leave you with, and this kind of goes back to what Eric was saying, conditional clearance letters, if you can get the regulator to give you them, are one of your best friends. It's a phenomenal tool in the toolbox that we as a community have, because it allows the regulator to give you a letter that is on its face an approval letter, which will satisfy various different entities, but that within the letter it has conditions that must be satisfied for that approval to be valid. And I've used that trick before on different HUD funding sites, as well as sites that are seeking some of those tax credits, to satisfy the letter of the law while still giving the regulator the flexibility to say, but also. And so it's a great tool in our toolbox, and we should, I know a lot of regulators are very leery of conditional clearance letters because they should be, right? We have a bad tendency to say, was it approved? Great. And then forget to actually look at the conditions, because we just look at what we wrote in our work plan. We forget to go back and look at the thing. But they are a really powerful tool.
Great. All right. Thank you all. Doing a quick time check here. I see we're at 1:29. So I'm going to go ahead and move us to end the partner panel. Thank you all so much. Really appreciate it. Go ahead and next slide, please. All right, so thank you again all for covering each topic that we had here in such depth, sharing your real world experiences and your feedback. I want to acknowledge that the water boards and DTSC recognize that there are differences in the way the agencies and individual case managers have approached vapor intrusion and decision making. We've been hearing it throughout presentations, throughout the panels, throughout Q&As and previous workshops too. This is really one of the main reasons why we are holding this workshop series, to address that feedback that we've heard and to create these spaces for discussion of challenging questions and topics. One of the big things we're doing is to address these differences is the Cal EPA Vapor Intrusion Work Group is following this workshop series with internal vapor intrusion trainings that will be rolled out to staff at DTSC, water boards, our local oversight programs, which manage petroleum underground storage tanks under the water board, and also the AB 304 local agencies to promote consistency through the cleanup process, conducting data-driven risk management decisions, and using multiple lines of evidence to support paths to closure while maintaining site-specific considerations. We've also had presentations and discussions on the use of screening levels and when to use them, and this is also something that we'll address in those trainings. Screening levels are appropriate early in the process, and as a case progresses into cleanup, as we heard all through the presentations and in the panel, it's very important to start working early with your regulatory team to develop those site-specific cleanup criteria with an emphasis on building and refining a robust conceptual site model and pursuing multiple lines of evidence that support paths to closure. Next slide, please. Waiting for that slide, but that's all good. We're going to transition into the open Q&A. So we do have some questions in the chat. Next slide, please. And I don't see any hands up right now, but we will be starting with the questions in the chat. And feel free if anybody has questions for our panel partners who just went through all these topics and discussions, please drop your questions in the chat for them, raise your hand. I know that, they all just talked for quite a while, but I'm sure they can talk a little bit more. We would love to hear more discussion. So let's see. I just want to say it's the same logistics again for previous Q&A sections. This is going to be open. Any of the presentations that you saw earlier, case studies, it's all open for questions and comments and feedback here. For those joining in the afternoon, if this is your first Q&A session, we do just have some instructions there on the screen for you. You can use the Q&A feature, use the raise hand if you would like to ask your comment verbally. And for those joining by phone, please press *9 to raise your hand and *6 to mute and unmute. So with that, I will go ahead and shift to the questions in the chat. So first up was a question to Eric regarding key considerations when integrating environmental cleanup requirements into planning of affordable housing. So Eric, you stated that if the city knew a site is contaminated, they will ask for testing. But what about sites, commercial lands, that has no record of contamination? Does the city have a mechanism to assess those sites that have no records of contamination?
Yeah, great question. So as you mentioned, the due diligence starts with the phase one. So, through the phase one, we're able to gather a ton of information on the past histories of the site. And then, typically the phase one will provide whether there's some additional work that needs to be done, some sampling. In addition to that, a lot of our sites we're using HUD funding. So, we have to go about doing the NEPA process. And so using databases like EnviroStore, GeoTracker, and even our own city GIS team has the ability to pull hazardous maps of, hazardous materials within a certain project boundary. Pulling all that information, and then through the actual NEPA review, we're able to gather some additional information. So, all that information helps provide kind of what the next steps would be. And so, but really, I think it starts with the phase one and kind of leaning on our consultants to be able to provide, what the next steps are. Hopefully that answered the question.
Great, thanks, Eric. Yeah, if there's any follow-up, please go ahead. You can raise your hand or drop something else in the chat. All right, next question. This says, thank you, Tom, and all of you for this webinar. What measures can be implemented to ensure the long-term management of vapor intrusion over the next century? And is it feasible to achieve complete control of that pathway?
That's a great question. This is Tom. Complete control is, as we know, there's two different types of vapors. If you have petroleum vapors, they will degrade over time when you have the vadosome, because the bacteria, it's oxygen related. And so, but with chlorinated, the PCE, TCE in particular, they don't break down in an oxygenated environment. So if it's under a building, those vapors typically will be there for many, many years. And so you say into the next century, it's something that the system has to be set up so that the installed system is robust enough to last many years, which from what I've seen, they typically meet that criteria. The other one is to have something where people continue to realize the systems are there and don't cut floor slabs, don't cut piping, check them out every so often. So I think it's the long-term maintenance and trying to keep the installed systems as simple as possible so that long-term maintenance is not problematic.
Yeah, thanks, Tom. Jonathan, go ahead. I see your hand up.
Yeah, I was going to mention the concept of complete control. Uh, I don't think that we'll ever have complete control over the VI pathway or any exposure pathway for that matter. And I want to just kind of mention that it's not about having complete control. Even with the vapor mitigation system, there exists some amount of VI that's occurring. The question isn't, is it gone? The question is the amount of VI that's occurring leading to an unacceptable risk? We can put in the beefiest barrier, we can put in the biggest vent system. There will always be some amount that gets in. It's just a question of doesn't matter. And I would say, we get hung up as an industry, and I think Nicole was talking about this earlier, the 0.03 attenuation factor from the US EPA study. She had mentioned using a 0.003 for reference. For those of you that have not read that EPA guidance, that 0.003 is the expected value. That's the median, right? If you took the 50th percentile, what it would be. What we typically see when we test systems that have barriers in them is when we have a strong enough signal strength, meaning that there's very high concentrations beneath the slab and we can measure indoor air at that same concentration. We have enough resolution. We see that these barriers are extremely effective by themselves at mitigating vapor intrusion risk. And there's a lot of reasons for that, a lot of science behind that. But the big thing is that they will bridge the cracks and gaps caused by the concrete. Right? The reason why concrete has so much VI is because it's not a perfect homogeneous isotropic layer. It has secondary and tertiary porosity. The barriers block that secondary and tertiary porosity largely. Now, is a barrier perfect? No. Every barrier you install, every barrier that anyone installs, will have some amount of defects. There will always be little imperfections in it that will allow small amounts in. But the reality of it is that having a 100 or 10,000 fold reduction in risk from vapor intrusion specifically is a reality for these systems. The difficulty that we face as consultants and as regulators is we know that that's probably true, but how do we demonstrate that with data when we have so much noise from everything else around us, right? When we collect an indoor air sample, it's pretty uncommon for us to get a clean indoor air sample anywhere. There's almost always something from just building materials or ambient. And so the actual quantification of these systems really becomes the dog wagging the tail about the protectiveness of them. And that's why using performance metrics, looking at things like pressure differentials for SSDS, or looking at site-specific attenuation factors you derive early on, can be a really helpful tool in our toolbox.
Yeah, great. I appreciate that follow-up. Meredith, I see you're unmuted. Was there something you'd like to add?
Oh, no, sorry. I didn't have anything to add to that.
You are totally fine.
Just
All right.
unmuted, just unmuted.
I just wanted to make sure.
Although
All right.
I could talk forever about any of these topics, but I think Jonathan did a very good job of covering that.
Excellent. All right. Thank you. Thank you. I will go ahead and move us on to the next question then.
I just want to add real quick. I mean, getting something in the building code would be awesome if we could eventually get that someday. That would be kind of like the holy grail where we could just install it and kind of forget it like we do with radon systems and sewer systems and the like. But until we have that, we're kind of at the status quo.
Yeah, I appreciate that, Craig. That was really helpful. All right, I'll go ahead and move us to the next question then. So, if a site investigation and risk management project has been under jurisdiction of either DTSC or of a regional water board only, how does the regulated entity know if or when the other agency might get involved or rule on site NFA or closure? So, this is more for the agencies. Ben, I see your camera's on. I'll go ahead and pass it to you.
Yeah, this is a great question. Really, if I'm at the end of the line with the regional board, how do I know that DTSC isn't going to come in and have opinions on site closure? And we really don't do that with each other except in very limited circumstances. When a project comes into either DTSC or the water board, We go through a memorandum of agreement process where in certain circumstances, one or the other agency has to take the project. Mostly this is if contamination is coming from an underground storage tank, that has to go to a regional water quality control board or a local oversight program. If the contamination is coming from a hazardous waste permitted facility that's not a petroleum refinery, that really should go to DTSC because that dovetails with our work in hazardous waste facility oversight. And outside of those two considerations, there are some other things where we'll look at availability of staff, whether the contamination is primarily affecting groundwater or is more of a soil vapor issue only, or whether there is some sort of unique situation such as 5 projects on the block are already overseen by the water board. Well, this project should probably go to them instead of adding DTSC to the mix. And we really don't look over each other's closure determinations because each of our agencies is pretty similar and is going to make a good decision. One other thing that can happen sometimes is if you go to a local agency that's certified by AB 504, on those projects, before they start, the local agency informs the water board and DTSC that they're taking on the project. That's our opportunity to say, hey, wait a second, we have 5 other projects on the block. Can you send this one to us? Or this has some really weird thing going on. We think we want to step in. We're also informed about the closure, but I don't think we have ever stepped in to push back on or stop a closure that another agency is doing. Now, I'm sure now that I've said that, someone's going to provide an example, but it's very rare and would only be in extenuating circumstances.
Yeah, great. Thank you so much, Ben. All right, I will go ahead. Oh, it looks like we do have a hand raised. So Ms. LaDonna Williams, let me go ahead. You should be able to unmute yourself. If you don't mind just stating your name and affiliation one more time, that would be great.
Yes, LaDonna Williams. I'm with All Positives Possible, a community-based organization that works on environmental justice, community health. While I listened to this series, I was really excited to hear about you guys taking on vapor intrusion. A lot of it is, high level techie stuff. And then others bring it down to real life. And that is where I am because I lived on a toxic dump site in Daly City for 10 years. My parents planted a garden, and neither one of my parents saw the age of 54. They both died before they made 60. And I listen to you guys and the approaches that you take on cleanup and risk assessment and things like that. And I just wonder at some point, we're now in 2026. When this happened to me, it was back in the early 90s. And nothing has changed as far as when you consider toxic dump sites, contaminated sites, brownfield sites, whatever name you all put them on. At the end of the day, your decisions you're making has decreased my family's life expectancy. I'm now in my 60s. Thank God I made it to 60. Literally in panic mode every year, and I got a birthday coming up. What changes will you guys make to stop allowing profits over lives? The developers come in, they got the big bucks. Okay, we get it. You've got this toxic dump land that you set out for the most vulnerable populations. You buy these plots of toxic dumps or junkyards. You then find some level that you call cleanup, and then you put layers over it and supposedly barriers over it, and then you divide it into three sections: some sort of industrial use, some sort of maybe agricultural use, and then housing. And you don't assess that part of housing, so that there is no record of that plot of land, that you decide collectively, all you agencies together, because folks are signing off, that it is okay to put the most vulnerable people on a toxic dump that they call their homes. I'm serious. I'm so disappointed to sit here and have to hear this. And then if I don't, then we're not informed and we can't inform others. But at the end of the day, you're still allowing homes to be built on a toxic junkyard. And if you follow it, and if there's studies, which there probably is, we're just not privy to them, of the life expectancy of the people that are living on it, or their quality of lives. We can show you pictures of sites, and they happen to have the name Village, Midway Village, which has been changed. That's another standard where you change the name of these sites after 20, 30, 40 years. So then when you go to search for records, you can't find them because the name has been changed to some other new name that makes it seem like it's a clean site. But we go to these documents or these agencies to try to get information, only to figure out, oh, there's no information. And then if you keep at it, years later, you discover, oh my God, we've been living on a toxic dump. That's what happened to me and my family, to where my mom and dad are dead. They're gone. My kids were raised without grandparents. And then we discover, oh my God, we were living on a toxic dump. And now we're working on a site with the very same thing: young families, tumors, suicides, constant bloody noses. Their quality of life is nil to none. You've got elderly on there, you've got disabled on there. And at the end of the day, you guys, with the stroke of a pen or a tap of a key, or we get together in these discussions and we make it normal to turn toxic, dirty land into living environments that you all sleep comfortably, saying, oh, well, it's clean. And look how much housing we have provided for the people. But you don't look at how many grave sites that you've created that could have been prevented. So I don't know if it's a question in there or it's just a comment because I'm blowing off steam. But at some point, we're 2026. When does this practice change to where you actually save lives and you actually protect lives? You don't just pretend like you do it in a nice put together report or a nice Zoom or a conference summit and claim that you're protecting the community's health when in fact you're killing them. So maybe that's a question. Does anybody within the regulatory circles ever stop and really say, you know what, you all, we have to change how we're doing stuff because we are literally killing people. And at the top of that list is Black Americans, because I cannot not bring that in to these spaces. We ain't heard enough of environmental justice in these spaces. So I'm just hoping at some point in 2026, there is a summit, forum, or something that's called together to say, you know what? We're absolutely changing the way we're doing things. We will no longer allow people to be killed or murdered by their housing, which was okay by us who's make those decisions. So I'll stop there. Thank you.
Hey, LaDonna, thank you for your comment. I appreciate it. I've been doing this since like 1998, and I can speak from my experience that the industry has, particularly around vapor intrusion. And I'll start off by saying that no agency, no development, nothing is perfect, but we've certainly, in terms of the technology, in terms of understanding vapor intrusion, indoor air, in terms of our investigatory techniques, our high resolution capabilities today, our understanding of chemicals from understanding of TCE more than we used to understand PCE and its daughter products, the more refined screening levels, other constituents, microplastics, PFAS, metals, the human health risk, the short-term levels that we now trigger and require mitigation measures versus what we used to. We've come a long, long way, even the technologies to remediate these constituents, the huge advancements in situ injections. We've gotten much leaner and meaner on thermal technologies. Some of even the older technologies, the excavation and SVE are much more informed by the high resolution site characterization. We've talked a little bit. I think part of the issue that you and your community may be struggling with is I can't speak to what decisions were made back in the 90s, but trying to look at, we're really keen for short-term, exposures and addressing those quickly. The long term, and there's others that are much smarter than me on this on the call today. And I know like Jonathan may also want to speak to this, but Ohia, Eric's on the call. The long-term, chronic effects of these chemicals and how they unwind versus epidemiologist studies regarding cancer and cancer clusters and communities. And do we have the data to support what your concerns are? The current data, versus what was collected many years ago. And do we have the funding and the ability to go in there and collect the data that you want us so desperately to collect to then actually make informed decisions on these long-term, exposures that we may not know or have a lot of understanding and how it relates with other confounding factors. And so it's very challenging. But
But Greg,
again,
can I
yeah,
add something in there? I'm
yeah,
not now
absolutely.
talking about my community. I just gave the background. The
Yeah.
the community that we've met with you all on are recent communities. These are people that have lived on the site within the last, say, 10 years, not 35 years like mine back in the day. I'm making the point that you're with all your new technologies and high-tech tools, why are these communities still having the worst health outcomes? Still the highest cancer burdens, the highest cancer rates and deaths. So my community, there's nothing that can be done. Majority of that community is dead and gone. Thank God I'm still here. But the community that I've reached out to you on is a current community with current decision making. And from the city to all you guys agencies, you've allowed these people to be living on a toxic dump. So my point is even with all that, you guys haven't changed how you do business. And at the end of the day, the people's lives and quality of health and lives speaks volumes over how much you guys think on paper that you're doing some good. At the end of the day, if these people aren't living longer, or they're constantly going to the hospital, or they're losing their loved ones or their own lives, then again, at what point do folks stop in their track and say, hey, we've got to do something better than what we've been doing?
I'll turn it over to others to also respond, but I do want to say, thank God you are still here and that we appreciate you coming on and bringing, continuing to bring this to the forefront.
Thank you. I
Yeah.
appreciate you saying
Yeah.
that.
Hi, LaDonna. This is Steve McMasters. Just wanted to share a little bit on this too. And thank you again for sharing your perspective and the issues that you're helping the communities address. I think it's really important for the audience and all the scope or the different people we have as part of this audience today to hear this side. And I do believe we've actually have made some changes, and I think that's why there's been a lot of frustration from redevelopers and everything, and that's why we're being so conservative on at least for the screening of sites, so we can get the data to make those better decisions than we have in the past. And let's just say that vapor behavior and the risk it poses still a lot of questions for us, and we're still trying to figure it out. And that's why we're really pushing to get more information and data to help us make better informed decisions. So we are super protective of the communities and people using these properties, but we do want to get these properties back used for the state. We just want to make sure that the people are protected, and we still have a lot of work to do on that front. So I just want to say thank you for bringing this up with everybody. That's all. Thank you.
Thank you.
You so much for the sharing and all the responses. Thank you so much. I'm going to go ahead and turn our attention to the next hand that's up, and that'll be Alejandro Fuan. You are able to unmute yourself, so go ahead and do so.
I want to give Jonathan an opportunity. Jonathan, did you want to also speak to LaDonna? I think it's important enough that we should hear someone from the panel speak on this too. Jonathan, you want to take a shot at it?
Sure. So I'm coming at this from the perspective of someone who's worked on the regulatory side and as an industry, and as someone that has two very young daughters. I think that part of the difficulty with the environmental industry is that we are in a constant arms race. And we don't usually think about it that way. But the reality of it is we are in an arms race with consumerism and capitalism. And there are constantly new technologies and chemicals being developed. And when they come out, they are the whiz-bang hot thing. And I can give you 3 examples that I think from what you were saying, Madonna, that probably will resonate with you. The first one is leaded gasoline. So when we first started using leaded gasoline, it was a sort of deal where it completely, consumers loved it. You got more miles per gallon, you got more bang for the buck, and it burned cleaner is what they thought. And then after we used that for a while, we figured out, crap, this causes some major problems in communities, particularly communities that are along roadways. And there was this lag between when this product came out and when everyone was touting the benefits of it. It was the hot new thing. And when we realized that we were harming people, and by the time we realized we were harming people, the damage had spread. And it takes a long time to repack Pandora's box. Another example is PFAS. I remember when my mom got her first PFAS frying pan. It was the non-stick coating. It was the great new thing. Look at me fry this egg, John. It's not getting stuck on there. It was in everything. And it is in everything. And we are only just now realizing the extent of PFAS contamination, not just in local communities, but in the world. It shows up in polar bears, right? It is everywhere. But from the 80s on, I don't know if you remember getting like a windbreaker and spraying it with that spray to like make it all waterproof. That was all PFAS. It was in every product. And we are at this point right now as an entity, as a community, both regulators, scientists, engineers, practitioners, industry, we all recognize, crap, this stuff is everywhere. We're trying to figure out right now how to clean it up. And we figured out it was everywhere roughly 8 years ago. And then we started kind of looking into it and digging. And so I guess what I'm trying to portray is that it can be frustrating as an outsider to look and see like, well, why are you guys sitting on it? Why is it not getting done? And I can tell you, I take this stuff very seriously. I have a history of lung issues in my family. It's part of why VI is there. My grandma and my grandpa both died from lung issues. My mom has lung issues. None of them smoked. They've all had the issues. I'm not looking good for me, to be honest. And it's something that part of why I do what I do, and part of why I try to push the envelope on how to improve these systems, is because I know that change does take time, and it's generational. This isn't a problem that I, John Sanders, can solve, but it is a problem that I can solve a part of. And then I can hand that part to the next person, and they can solve a part of it, and they can hand it to the next person. And it's tough, because when you talk about communities that have contamination, and you talk about communities that are suffering from this exposure that happened because of consumerism and capitalism, you want to have this relief. You want to have this fix-it problem now. That's just not something that we have the capability of doing a lot of times. It's a long-term solution of incremental improvements in people's health. For perspective, I know this gets a little technical because I'm a nerd and I love talking technical, but when we talk about what acceptable risk is, and you heard them talking about 10 to the minus 6, the level that we are supposed to be regulating risk to is a 1 in a million chance of developing deleterious health effects over a roughly 26-year period of exposure. Now, is that no risk? No. 10 to the minus 4, which you may have heard in Nicole Fry's talk, I think she might have mentioned it briefly, that's a 1 in 10,000. So we are trying to reduce these risks as much as we can. We'll never get to zero risk. It's just not possible. But we can do everything we can to mitigate. I can tell you that as someone that has almost exclusively done vapor mitigation systems and system design for the last 5-6 years, I probably can count in years the number of years that I have improved someone's lifespan, how many extra years of life they have. What I can't do is point at a person and say, I saved that person's life. But I just thought that perspective might be helpful. I would encourage you, LaDonna, if you want to talk about these things, sometimes it's difficult to talk to regulatory oversight agencies. My contact information is in this. Feel free to reach out. And I'm happy to talk to you and your advocacy group and do my part for the community.
I didn't know if I was able to still talk, but thank you very much.
Cheryl?
And I know that we've answered this question very thoroughly, and you've heard a lot of really good responses. And the one thing that I wanted to add in is there are a number of us that are passionate about environmental justice. As regulators, we want to make sure that we're serving all Californians equally. And it breaks our heart also that health outcomes are different for different communities. We're really trying to do it better. You heard us mention the guidance that came out in 2023. We're trying to create better guidance, be more thorough, be more consistent. We don't want to approve projects for low-income housing or communities of color that we wouldn't feel comfortable living in. So we really are trying to push the envelope of the science. And thank you for raising the concern and continuing to push us, because we know there's always room for improvement. And so keep pushing us, and know that we are trying to do our part as well. So thank you.
All right, great. Thank you all very, very much. And so we are now at 2:05. I recognize we are a little over time at this point, and I think that discussion warranted it, absolutely. I do want to make sure that we get to the last 2 questions that we have. So the next question, this is for Jonathan. Could you please explain more about the circumstances of a conditional letter, of the conditions letter? Conditional remediation, completion certificate, conditional project approval, conditional case closure?
Sure. So a lot of times it's going to come down to, and we've all been there before, right? We write our report, or whatever the thing is that's supposed to satisfy our compliance obligation, and we submit that to DTSC, and there are comments, right? And there's a review cycle, and sometimes that review cycle can go back and forth more than once. Where a conditional letter can be very, very helpful is in those situations. If the comments are editorial in nature, or clarification, or expanding on things, but that the overall conclusion, which is this building is suitable for occupancy, if that conclusion is not going to change, it's just the backup that's going to change and the other things, that's where using a conditional clearance letter can be a very powerful tool. And the conditional clearance letter would essentially say the regulatory oversight agency concurs that the engineering controls are adequately controlling the exposure pathway, therefore no objection to clearance for occupancy. This approval is conditioned upon the following, and then they can give bullet points. Revise the report to address our technical comments in Appendix A. Add in these field notes. Tell us about whatever the thing is, whatever the little items are, they're ticky-tacky. Those are the things that you can handle in that phase between TCO, temporary certificate occupancy, and PCO, permanent certificate occupancy. So getting that conditional approval letter can allow things to move forward and still getting all the stakeholders what they need. You're still satisfying the DTSC or the water board's requirements for those details. You're not ignoring them. You still give them the opportunity to ask those questions and get those answers. But if the end question, this is particularly relevant if you have a site where, let's say you have indoor air data and the indoor air data is fine. Well, great. Let's solve all these problems, but let's get things moved forward and let's get occupancy started slash let's get the funding mechanisms and all that stuff where we satisfy those requirements. It can also be super helpful on the front end, right? If you're doing a traditional corrective action plan slash corrective action implementation plan, or maybe your corrective action plan is conceptual in nature and your corrective action implementation plan has all the nitty-gritty details, conditional approvals to move forward with the corrective action plan can satisfy different requirements from your funding mechanisms. While still giving you as a condition of approval, you must submit a corrective action implementation plan, which has the details, the construction plans, the CQA plan, those types of elements. There's other use cases that are scattered about, but I want to be respectful of everyone's time, and I think that gives a flavor of where I would use them. You do have to make sure your regulator's okay with it, though. So.
Thanks for that, Jonathan. And I will also say, yes, as Jonathan mentioned previously, his email address is in the chat as well. I'm sure he'd be happy to chat more about that as well.
I do like to talk.
Just a little, right? It's great. All right, let's see. So the final comment that was in the chat was just, acknowledging, yes, we're really all in this together. There's only so much that each agency and each group can really do together. And the theme of the workshop really has been collaboration, early engagement, working together, sharing the schedule, sharing those necessary milestones, because what we've really been hearing today is that there's so much crossover between different industries, really, right? Because you have the financial, you have the redevelopment, you have our environmental practitioners, and you have the regulatory. And being able to come together and have those really honest conversations about the needs and milestones is just what is absolutely necessary to really come up with a plan that will be protective of human health and see successful project outcome. So, thank you for that comment that was in the chat too. And let's see, I think we have no other hands raised. I believe that we have no other questions. I do see that we are at 2:10. Thank you all so much. Colin, if you don't mind sharing the slide deck once again, we'll go ahead and wrap today. So with this slide, there might be some animations you could just click a couple times. It says thank you, everybody, and it has the DWQ-vapor intrusion at waterboards.ca.gov email. Go ahead and click again. That should show up. And we really just want to thank everybody on behalf of the Kelly PA Vapor Intrusion Work Group, our industry presenters and panelists, to really just thank you all for being with us here today. It's been long, and we really appreciate your time and all of your engagement. We hope you found the presentations and discussions helpful today. And I do also want to give a quick note. There is a Zoom survey that will be sent out to all attendees after the workshop concludes. We would really, really appreciate your feedback. So as always, feel free to email us any questions, comments, or feedback. Next slide, please. All right, and so our team was very busy in the background. I believe that this slide is now fully updated and information was just dropped into the chat. FTP is now back up and running. You should be able to access it and be able to download previous workshop slide decks and recordings. The slide deck and recording from today's workshop will be available at the same FTP with the same username and password in about 2 weeks. So please keep that in mind and let us know. Please email us if you are still experiencing issues. We've done a lot of testing on the background, so we're pretty sure it's good to go. Next slide, please. All right, so that one also, yes, we are posting all of the workshop recordings on the State Water Board and Department of Toxic Substances Control Vapor Intrusion websites. So you can also find the recordings there. Again, it'll take us about 2 weeks to get the recording from today's workshop posted onto our websites. Next slide, please. All right, so final plug, very final reminder. We have one more workshop coming up. Our final workshop in this series is scheduled for June 17th from 9 a.m. to 2 p.m. again, another big one. And it will focus on vapor intrusion data. This is our big finale, and we would love for everybody to join us. Please keep an eye out for the public announcement and registration. Thank you again so much for joining us, for sharing your questions, your experiences, for engaging with us. We hope you have a fantastic rest of your day, and we hope to see you in June. Bye.